Hello, 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 hello.
Good morning, everyone, and welcome to the 10th International Conference on Statistics for the 21st Century 2024, jointly organized by the International Statistical Fraternity, the Department of Statistics, School of Physical and Mathematical Sciences, University of Kerala. Actually, this journey, the journey of this conference, which started as a brainchild of Dr. Satish Kumar in 2014, has reached a serious stage when we successfully complete 10 years of having intellectual and academic collaboration in an international level successfully. So we are entering the inaugural session of the conference, and nothing is possible without the grace of the Almighty. I request Jiva for the prayer song.
കണ്ണിമയ്ക്കാത്ത കാവലാള കാത്തരുൾ ദൈവമേ കണ്ണിമയ്ക്കാത്ത കാവലാള കാത്തരുൾ ദൈവമേ കരുണയാകുന്ന കാന്തിയാലിന്നു പുൽകുമാറാകണേ കനവിലും എൻ്റെ നിലവിലും നിന്റെ സ്നേഹമേ കീണമേ കരളിലായി ചേർ ചേർന്നു വഴിയിലാകെ കാക്കുമാറാകണേ.
Thank you, Jiva. Now I request Professor Manoj Chako sir, the head of the Department of Statistics, University of Kerala, to welcome the gathering.
Respected chief guest of this function, Professor M.A. Professor Dr. C. Sadish Kumar, the president of this inaugural function, Professor A. Mathai, Professor Yakin Thomas, Professor Kalyan Damsel, Professor P.G. Shankaran, delegates of the conference, my dear colleagues and dear students. It's given me a great pleasure to welcome the inaugural function of the International Conference on Statistics for 21st Century. So this is 10th International Conference in succession. So we started the procedure in 2015. So regarding the Department of Statistics, so as all you know, this is the second department to start a PG program in statistics in India. So we established in 1945. Now, Department of Statistics offer two PG programs, one in statistics and another in MSc Applied Statistics and Data Analytics. Although we have 25 research scholars doing their PhD in this department, including 3 international students. So in the next year, that is in 2025, we are going to celebrate the 80th anniversary of the Department of Statistics. So as head of the Department of Statistics, I humbly request the cooperation and support of all of you to the activities of the Department of Statistics in the next year, and we are planning to organize a series of events in 2025. So with these few words, I am entering my duty of welcome the gathering. We are fortunate to have Dr. M.A. Umen, the renowned economist, to inaugurate the conference. He is an honorary professor, Center for Development Studies, Trivandrum. He is the first teacher of Economics Department, University of Kerala, and was the first professor at Calicut University, and he is the founder of John Mathai Center at Thrissur, one of the prestigious institution in economics. He wrote several books, I think more than 30 books, and several articles on the issues such as democracy, development, decentralization, and economy of Kerala and India. He worked as economic advisor of Botswana government. And Dr. Umen also held several positions, including chairman of Institute of Sustainable Development and Governance, chairman of 4th State Finance Commission, Government of Kerala, and Department of Kerala Economic Association. It is my privilege to welcome you to start this event. On behalf of the Department of Statistics, University of Kerala, and the organizing committee, I extend a warm welcome to Dr. M.A. Umen. Dr. C. Sadish Kumar is the president of this inaugural function. He is also the chairman of this conference. There is no need for welcoming Dr. C. Sadish Kumar, sir, but formality on behalf of the Department of Statistics, I welcome Dr. C. Sadish Kumar, sir, to this inaugural function. Professor A. Mathai is no need for introduction to Professor Mathai to the statistics community. He is presently emeritus professor at McGill University. He is always with all the academic activities of the Department of Statistics, University of Kerala, not only for the Department of Statistics, but for all the Statistics Department of Kerala. He is extend his support all the academic activities without any condition and without any demand. So is on behalf of the Department of Statistics, University of Kerala, I welcome Dr. A. Mathai sir to this inaugural function. Professor Yakin Thomas sir is a former head of the Department of Statistics and also my own supervising teacher. He is always supportive to all the academic activities of the Department of Statistics. And he is very simple and is an inspiration to all of us. I welcome Dr. Agwin Thomas sir to this inaugural function. Professor Kayan Raman sir is former faculty at Department of Statistics and my own teacher. He is attending the conference online mode. So I welcome Dr. Kalyan Raman sir to this inaugural function. Dr. P.G. Shankaran, former Vice Chancellor, Cochin University of Science and Technology, and he is also a well-wisher of the Department of Statistics. He always supported all the academic activities of the Department of Statistics. I welcome Professor C.G. Shankaran to this inaugural function. So we have participants from different parts of the country and abroad. Dr. Ashok Sarkar from Canada, Dr. Romeo, and other participants, online participants are there. So I welcome all the delegates of this conference, all the keynote speakers, invited speakers, and all the students to this inaugural function. So Dr. Riaz, the organizing secretary is here. So I welcome Dr. Riaz to this inaugural function. And I extend all, also Shubha teacher is here. I welcome Dr. Shubha to this conference. So on behalf of the Department of Statistics, I welcome each and everyone to this conference, and I wish all the success to the conference, and thank you.
Thank you, Marit sir. Now I would like to welcome Professor C. Satish Kumar sir, the chairman ICSTC, the director School of Physical and Mathematical Sciences, and the chairman International Statistical Fraternity for the presidential address. A few words about sir. Actually, we don't need a formal introduction, of course, but I think I should say that he's a person with extreme dedication and sincerity to the subject and to his profession, and he's a person who works so hard without any. Sometimes we feel, how can a person do this to such level? He's a person who works so hard till he reaches the goal, and I think he's a motivation to all of us here. I welcome you, sir, for the presidential address.
A very warm greetings to all. Good morning, good afternoon, and good evening. It is my pleasure, it is with immense pleasure to welcome you all to this, the inaugural function of the 10th International Conference on Statistics for 21st Century 2024, held in conjunction with the 5th Annual Convention of the International Statistical Fraternity. This grand event has been organized by Department of Statistics, School of Physical and Mathematical Sciences, University of Kerala, in association with the Kerala Statistical Association and American Statistical Association. This day is indeed auspicious as it brings together some of the most distinguished statisticians and experts in statistical sciences from across the globe. For the next 4 days, we will have the privilege to interact and exchange knowledge with these eminent personalities through a hybrid platform of offline and online sessions. Allow me to acknowledge and express my gratitude to the illustrious luminaries in attendance of this international conference. Our great professor, Professor A. Mathai, Emeritus Distinguished Professor of McGill University, Canada, and Chairman, Mathematical and Statistical Sciences Trust, Professor B.C. Arnold, Barry C. Arnold, Emeritus Distinguished Professor, University of California, USA, Professor N. Balakrishnan, Distinguished Professor, McMaster University, Canada, Professor Dietrich von Process, Linköping University, Sweden, who is the chief editor of the multivariate analysis, Professor Ron Wasserstein, Executive Director of ASA, Professor Andreas Filippo, Greece, the former professor who instituted the University of Patras and former education minister of that country. Professor Katsiashvili, Carlos Katsiashvili, Georgian Technical University. Professor Thomas Matthew, University of Maryland, USA. Professor Carlos Coelho, Nova University, Portugal. Professor Peter Lohmanter, Sweden. Professor Indranil Ghosh, University of North Carolina. Professor Venkateshan, former director of ICMR, Chennai. Professor Vikas Sinha, ISI Kolkata. Professor Gopal Basak, ISI Kolkata. Professor Shipra Banik, Independence, they are all online. Independence University, Bangladesh. Professor Onuka, Kebbi State University, Nigeria. Professor Ashokan Bariat, Memorial University of Newfoundland, Canada. And several others. We are always honored to have several distinguished scientists, statisticians, and researchers representing world-renowned institutions in the, the high-ranking universities, as well as Indian Statistical Institute, Indian Institute of Technology, ISER, IIST, etc. I apologize for not being able to mention every esteemed the name due to time constraints. This conference packed with an extraordinary lineup of over 20 keynote and plenary sessions or talks and more than 80 invited presentations, including special invited lectures by leading scientists in the area, more than 100 contributory presentations. All sessions are designed to foster collaboration and innovation, making this a truly mega event. The detailed schedule is available on conference website as well as you can see from the program chart. The conference began with a pre-conference workshop 2 days back, December 10 to 12, on distribution theory and its applications, which offered hands-on training as well as valuable insights to several participants as well as our students. On this occasion, we wish to honor our beloved professor, Professor Mathai, a true legend in the fields of statistics and mathematics, a scholar with a truly beautiful mind. His groundbreaking contributions have not only shaped the foundations of our disciplines, but have also inspired generations of researchers. To quote Aristotle, excellence is never an accident. It is always the result of high intention, sincere effort, and intelligent execution. Professor Mathai exemplifies this excellence. Being with him and sharing the stage is not just a personal pride for me, but a profound privilege. His life and work remind us of the infinite possibilities of the human intellect and the importance of perseverance and passion in the pursuit of knowledge. We will have so much to learn from his wisdom and legacy. To honor this occasion, I am thrilled to highlight the announcement of the establishment of the award for Best PhD Thesis Award by our esteemed Professor Umensa in 3 disciplines on behalf of the Mathematical and Statistical Sciences Trust. This award, in fact, celebrates not just academic excellence, but also the transformative impact that Professor Mathai's work has had on the global scientific community. Today, we have the great privilege of having the renowned economist, Professor M.A. Uman sir, to inaugurate this international conference. Professor Uman sir is not only celebrated for his profound contributions to economics, but also for his unwavering commitment to ethical principles and social justice. A remarkable example of his integrity is his tenure as the economic advisor to the Botswana government. In a bold move, he publicly criticized the country's central budget for disappropriately subsidizing wealthy businessmen, highlighting its misalignments with the principles of equity and fairness. Despite the subsequent shortening of his tenure by the Botswana government, Professor Umme stood firm in his values, embodying the kind of courage and moral clarity that the world desperately needs. People like Professor Mathai and Professor Umen are very rare to be found among us. They remind us the importance of unwavering ethics, dedication to knowledge, and the courage to stand up for what is right. Their lives serve as beacons of inspiration, urging us all to aim higher, work harder, and contribute selfless to the greater good. I encourage all participants, especially students and young researchers, to make the most of this opportunity by attending as many sessions as possible. Both those who are here attend offline and others also via online. Your active participation will enrich your knowledge and broaden your horizons. In closing, I extend my heartfelt gratitude to each one of you for your support, cooperation, and blessings, which have made this event possible. Together, let us work towards generating new knowledge that benefits society and meets the demands of the 21st century. Thank you all. I wish you a very successful and inspiring days ahead. Thank you so much for this. I remind. Thank and ladies.
Thank you, sir. We have reached the most important part of the inaugural session. For us, we have today our chief guest, Professor M.A. Umman. As he was introduced very correctly by the speakers before me, we have an eminent economist and an eminent academician with us to inaugurate the session. He's an honorary fellow of the Center of Development Studies, Trivandrum, and also an alumni of the University College, as well as the Department of Economics, University of Kerala. He has collaborated with the Botswana government in as an economic advisor, and is also a person who was able to provide an accurate and scientific curriculum for the Department of Economics in various universities across Kerala. A very rightful person to inaugurate the session. We are extremely privileged to have you with us, sir. And I request you to light the lamp and deliver the inaugural address.
തുടങ്ങാം. My illustrious friend, Professor A. Mathai, esteemed colleagues and friends, I feel humbled, if not honored, to be here on this occasion. I am certainly not qualified to inaugurate such a great academic event. Statistics is not my subject. I learned a little bit of it at the feet of the great statistician, teacher, and scholar, Dr. U.S. Nair. Now, that was just averages. What you are handling is the higher realms of statistics. Friends, I am a nonagenarian like my great friend Professor Mathai. I knew him for several years now. He's a long-standing friend. And I have seen him, observed him, but not read much of what he wrote, for because that is not very intelligible to an ignorant person like me. As Professor Satish has rightly said, he's a legend, but very unassuming and dedicated to his profession. He's a great example for the academic community of the world. And the other day, when he visited me with Professor Satish Kumar, I asked him what to talk about. He said, anything. To talk on anything or something. I thought I should talk about the Indian development, a topic on which I am trying to make a book, even at this ripe old age. My friend makes marathon lectures, engages in debates, and is fit as a fiddle when he talks. Now, in his presence, when I speak, I want to say that the mathematicians have conquered the economics profession from Jan Tinbergen, who was the first Nobel laureate in economics, to the latest Asimov Moglu, or that profession, or earlier than Claudius Goldin. 55 awards, Nobel Awards were given. Of this, given to 95 economists. But the majority of them are mathematicians. Although mathematics and statistics are eminently required for economics, but mathematics and statistics are not economics. And I was one who criticized making economics models great abstractions, far removed from theory. Even one of the Nobel laureates, early 1987 award recipient, Robert Solow, he wrote a book. The title of it is Economics for the Curious. Economics is not for the curious. He said economics has built models and indulge intellectual pursuits for the fun of it. Can intellectual pursuits should be pursued for the fun of it when the economy and the people suffer? It was in this background of that one has to think of the question of Indian development, and statistics in the 21st century becomes relevant for the Indian development. Mind you, millions and millions of students have passed the primary school in India, and the latest reports, not official, show that the majority of them do not know how to read. If you do not read, how do you learn? You are easily led by others. So this is where good statistics, reliable statistics as a correct measurement and evaluative tool is required. So you should know the dynamics of the motion of society and economy of a country. It is in this juncture that at the last lap of my career, academic career, I thought I should write a book. More than 35, all of them useless. I don't, every time I write, I am not very happy. But this I thought should be something different. Now, how do it is different? Economists, by and large, work for enhancing the value of commodities for what they call GDP, increasing the rate of growth of GDP. Yesterday, the new Reserve Bank governor said that he will pursue what the former governor has said, to uphold the rate of growth to a level of 2-digit level. Is the rate of growth the real Indian development? My categorical answer is that it is not. Expansion of commodity flow or service flow are good, but they are means at best. But you should not confuse means with ends. You should not confuse expansion of commodities or GDP with the well-being of the people. On August 14, 1947, I was a student at SB College. All of the students at 12 o'clock were wearing Gandhi cap and shouting Bolo Bharat Mata Ki. And after that moment, Pandit Jawaharlal Nehru made his historic speech called later the Tryst with Destiny. We were fortunate to listen to that. It promised, when the world is sleeping, India is awakening to freedom. India is capturing its soul. I was a citizen of George VI, but 1947, August 15, after 12, I became an Indian citizen. Am I still an Indian citizen? What is citizenship? If you do not understand the full blossoming of the meaning of citizenship, it can come only when the right statistics to evaluate what is happening are daily food for the scholars to nourish the society. Friends, in this context, what I thought was that we should have a new understanding of Indian development. The idea, I am finishing my book. In a month's time, it may be over. It is built on a tripos. The idea of India, the Indian Constitution, and the theory of Development is freedom, dignity and equality. Development is freedom, dignity and equality. So, on this report, the idea of India, first raised by no less a person than Rabindranath Tagore in his book Indian Nationalism in 1917. He said, the idea of India is part of the human development. Today, in his latest book, Shashi Tharoor has said, the modern idea of India is robustly rooted in the idea of the Indian Constitution, secular, legal, and pluralistic. It is not that somebody is born into a religion or into an identity. You are an Indian. The idea of India is not based on greater dignity. Some are top citizens, the others are poor citizens, what Ambedkar calls a social lepers. This graded, stratified dignity, it is the evaporation of that stratified dignity, what is called Indian development. India's development, I never call India's development. Today and the last 3 days, Dr. Panagaria is in the town, Trivandrum. He has written a book. He is chairman of the 16th Finance Commission. It is Awakening Giant. India is an awakening giant. He says that in the first millennium, a good part of it, 30% of the world's GDP was shared by India. India was so rich. We should become like that. But that is not India. India, the Indianism is to build social justice so that the marginalized and the downtrodden becomes real citizens. Why? How can it happen in a country like India, where now, based on the latest statistics of world inequality data, 50% at the bottom today has only 15% of the income of the country. 40% has 27% of the income of the country, whereas 10% has 58% of the wealth, the income of the country. There is statistics for wealth, asset distribution. The latest shows that we have improved, but the statistics collected here omitted big households and several items which they own. So you can show progress. Exaggerated knowledge can misuse, statistics can mislead. Friends, I do not want to continue because I have reached data with me. I have been working on that. But I can only say that unless and until we have the right knowledge about what is happening to the climate of the country, the environmental overkill that happens in this country. Among the three polluters of the world, number one, USA, China. China is number one. USA, now today, USA, China, and India contribute to 42% of the GHG, that is the greenhouse gases. Although they will say that 80% of the stock of GHG was accumulated by Canada, Japan, USA, and the European countries. But today we are the top polluters. How do you use it? And that is the quarrel that ended last November 23rd conference at Baku in Afghanistan, Azerbaijan, and last week another conference on plastics in South Korea also ended in a fiasco, because today we have politicians like Donald Trump, who says drill, drill, drill. That is, drill the bowels of the earth. It doesn't matter. It affects the climate, the warming system. So, what is development? Development is enhancing freedom, equity, and justice and dignity. Two books I am never tired of reading and rereading. One by Amartya Sen, written in long ago, long back. The other by Abhijit Banerjee and Esther Duffel, Good Economics for Hard Times. They say the allocation of resources should be governed by not by prices or profit, but also governed by compassion and caring and the dignity of the human soul. So our struggle is to enhance freedom, fight unfreedom, like ill health, ignorance, superstition, insecurity of life. Fight, we have to. How do we enhance freedom? By fighting unfreedom and enhancing our capabilities. Enhancing our capabilities. And at least I am happy to be present here at this moment. I will stop immediately because I am presented, because I can go on like this nonsense. What is freedom? Freedom is the right to choose, the capability to choose the career that you have reason to value. Here is an eminent professor who has the capability to choose the life that he has reason to value. So he is the most blessed person to be a free man in its quintessence. Thank you.
Words of wisdom. Actually, we are overwhelmed by your words, and thank you for taking time to be with us. I now request Professor Yagin Thomas sir to honor Professor Umman sir by. Thank you, sir. We now reach another highlight of today's session, honoring of Professor A. M. Mathai in commemoration of his 90th birthday, which is due on 28th of April 2025, and as a thankful gesture to his various contributions to the field of statistics. As we all know, Professor A. M. Mathai does not require an introduction, but I think it's my privilege to say a few words about him. Professor A. M. Mathai is currently the Emeritus Professor of Mathematics and Statistics, McGill University. He is actually described as an Indian mathematician who has worked in statistics, applied analysis, applications of special functions, and astrophysics. And his research contributions cover a wide spectrum of topics in mathematics, statistics, physics, astronomy, and biology. He is a fellow of the Institute of Mathematical Sciences, National Academy of Sciences of India, and a member of the International Statistical Institute. He is a founder of the Canadian Journal of Statistics and the Statistical Society of Canada. He was instrumental in the implementation of the United Nations Basic Space Science Initiative from 1991 to 2012. Actually, his contributions to the field of statistics and mathematical sciences is so large that there is a paper available on the scientific endeavors of A. M. Mathai, an appraisal on the occasion of his 80th birthday, which was co-written by J.S. Hubbold and Mathai, sir. It was brought out by Axioms Publications, and I think every statistics student should go through that paper. Professor A. Mathai has published more than 25 books and more than 300 research publications. In 1998, he received the Founder Recognition Award from the Statistical Society of Canada. He is a fellow of the, he was born, just going to a short brief history, he was born in Arakulam near Palai of Idukki district. After completing his high school education in St. Thomas School, Pala, he joined the St. Thomas College with record marks. He is a gold medalist from the University of Kerala, and he joined St. Thomas College, Pala, as a lecturer in statistics. That is the point from where he started his career in the statistical academics. It happened in 1961, and he obtained Canadian Commonwealth Scholarship in 1961 and went to University of Toronto, Canada. And from the University of Toronto, he then joined the McGill University as an assistant professor in 1964, and then as an associate professor till 1978, and he became a full professor at McGill University in 1979. And served in the Department of Mathematics and Statistics until 2000, and from then on till this moment, he is the Emeritus Professor of McGill University. His contributions to his motherland and Kerala is is again unquestionable. He is as the director of the Center of Mathematical Sciences, Palay, since 1985. He has spearheaded various research programs to improve the research in statistics and mathematical sciences. And coming to our department, he's a mentor and guide to the department. He was always there in all the programs we have conducted. And as a person, I think he's a very enthusiastic, pleasant, kind and gentle person. Actually, we don't feel that he's such a great professor when we interact with him. We are so happy and lucky to have your association, sir. And now I request Professor Oman, sir, to please honor him with the Ponnada. This is just a token of our love to you, sir. It's a photo that was hand painted by a student. I request Satish sir to please hand over the photo. Thank you, sir. As a simple example for the contributions of Professor A. Mathai to the field of statistics in Kerala and India, we have some announcements to make, and I request Professor Uman sir to please make this announcement.
Friends, it is in the fitness of things that this department is instituting the best PhD thesis award in honor of Professor A. Mathai. Let me read. In honor of the renowned statistician, Professor A. Mathai, the Mathematical and Statistical Science Trust has decided to institute national level best thesis awards in 3 disciplines: statistics, mathematics, and physics. The award constitutes of a certificate of merit and a cash prize of 10,000 each. The award will be distributed during the ICSTC conference conducted each year, and the expenses for travel accommodation as well as the registration fee for the awardees will be borne by this trust. Thank you.
I now request Professor A. Mathai sir to please say a few words.
Dear friends, this is one in a series of conferences that are planned by Dr. Sadish Kumar and being successfully conducted every year. And this year also, I understand that a large number of papers are going to be presented online and offline here. So I wish all the success for this particular conference, and I hope that the youngsters will have good opportunity to get a lot of new ideas so that they can pursue research as well as benefit in their career. Thank you.
Mathai sir, I request you to please announce the dates of the coming year's WSTA and ISTC 2025.
WSTA. Yeah, dates for the coming year. WSTA, Webinar for Statistics, Theory and Applications 2025, will be on 29th June to 2nd July 25. 29th June to 2nd July 2025. ICSTC, this conference for 2025 will be 11th to 14th December 2025. Pre-conference workshop from 8th to 10th December 2025. So I repeat again, WSTA 2025, 29th June to 2nd July, and ICSTC, the present conference, 11th to 14th December 2025.
and pre-conference workshop will be from 8th to 10th December 2025. Thank you.
Thank you.
Thank you, sir. Now it is time to release the souvenir and abstracts. I request Woman sir to please release the souvenir, and I request Shankaran sir to please accept the same. Thank you, sir. Now it's time for felicitations. We have our great professors with us to bless this conference. First of all, Kalyanaraman sir, is he there online? As we all know, Kalyanaraman sir was a professor of our department. He was actually the person who started computational analysis in the University of Kerala, and I think maybe in the whole of Kerala, he might be one of the first persons. So he's available with us online. Kalyanaraman sir, yeah, can you hear us, sir? I request you to please say a few words of blessings. Thank you.
Okay. So good morning. Good morning to all in the gathering. And someone will, if Dr. Oman is unable to hear what I say, just to tell him I am paying my respects to him. Kalyan Raman is paying respects to him. So if Oman sir can understand that I am here, I will be very happy about it and that. But so, for felicitation, I have been asked to say a few words. I think that you are able to hear, it is audible, and as far as you are concerned, that is the 10th year in succession, we are celebrating the conference, that is a decennial year. Perhaps it's a great function, and automatically the function has happened with Dr. Umman coming in to inaugurate it. And I don't think that another person will be more suitable for this, for reasons may not be known to you, but known to me. And I'll just take about a few minutes to tell you what relation Dr. Umman has with the Department of Statistics as well as teachers of Kerala. See, you all know that the lecturer was paid 250 rupees in 60s, late part of 60s, and later it was raised very frequently, infrequently, in using the state level pay commission adjustments. So, when the University Grants Commission scale came in 1976, we were not paid. We were not allowed to get that. Not only there, continuously we were not allowed that. That is 1986 also, UGC scales were not paid. Only the state level pay commission was instituted, and university teachers as well as teachers in Kerala had to get the salary given by the state commission. 1988 commission was headed by Dr. Umman. Dr. Umman was the operational part of the particular commission, so that when we requested Dr. Umman to include our case also, that is the university's case regarding salaries, he said, please wait, let this be complete. We will have a separate, commission for university teachers, and we will think of doing that at a later stage. And immediately after the state commission, that is 1988, for university teachers and college teachers. And at that particular time in Kerala, the pre-degree education coupled with college. So that was a great bottleneck as far as we are concerned. So Dr. Uman was thinking about how to get rid of this. And also, the government was not completely favorable to UGC scales. And there was a part of the government which was very, say what you call, not very favor of, not in favor of giving UGC skills for university teachers. And so they were not ready to give enough material for women, so to work on that and then give the report. So Dr. Woman did something very. You may say that how Dr. Woman and statistics are connected. This is the way in which Dr. Woman and statistics are connected. Dr. Woman developed a model for the university pay scales, and using the model, a sample survey was conducted, and based on the sample survey, we estimated the percentage of university teachers and pre-degree teachers. So out of 100, it turned out to be 51 is to 42. 51 is to 48. And Dr. Uman said, okay, we will give 1% more for university teachers, so that this turned out to be 52 is to 49. 52 is to 48. That's what happened. 51, 49 turned out to be 52, 48 later. And then, since not in favor of the pay scale, they tried to put the entire machinery to work and find out the percentage whether it is correct or not. You know what happened? It turned out to be that it is 52 is to 48 as was predicted by the commission. So actually they asked how this happened. Women jovially said it is by magic that we got this particular. So statistics actually helped the university teachers in Kerala as well as teachers in Kerala totally to receive the UGC scales during the commission of MA Woman in 1988. So we cannot forget Dr. Woman. Not a single teacher in Kerala can forget Dr. Woman, and I would request each one of them to pray for his continued health for in his activities that is happening now. So this is something that I wanted to say. So bringing Dr. Woman to inaugurate the 10th year international conference on statistics for 21st century is the most appropriate thing as far as we are concerned. So I thank you for that, and I say a little about the conference as such. So the conference as it is going on very well. The 10th year conference is going on, and you'll see that the organizers have generated a YouTube channel called Stack Kerala. I do not know how many of you really know about it. They have uploaded all the papers presented over the last 10 years or whatever that was possible for them. So it came out that I counted, it came out like 2,574 hours of YouTube presentations are available online for anybody to look into it at any time. So this is something that is a great achievement, and I appreciate whoever that is responsible for this, for making this available for researchers is most important. So now you see one thing, that is the amount of information that is available is very big. Unable to get to know what is available. So if you can just organize yourself with a project to list the number of presentations with the appropriate kind of navigational possibilities, it will be great use, and possibly you may think of doing it later. In about 1 or 2 years, you can achieve that. So if that is the case, there is going to be a great, what do you call, thing thing for research workers as such, because every presentation is available there, so you can really do that. So these two things which I wanted to say. So I once again thank and I request Dr. Uman whether he to accept my respects and continue to have the good instance towards that. So definitely it is something that I will cherish in my life for the next few years. And regarding the conference, I wish all success for every participant to have whatever that they wanted to give, to continue to have that. Thank you all.
Thank you, sir. Now I request our former HOD and Emeritus Professor, Professor Yagin sir, to please say a few words of blessings.
Professor C. Sadish Kumar, the chairman of this function, Professor A. Mathai, a living legend in statistics and an alumni of this department, Professor M.A. Uman, a living model for a progressive researcher, Professor Manoj Chaku, head of the Department of Statistics, Professor P.G. Shankaran, the former Vice Chancellor and Professor, Department of Statistics, Cochin University of Science and Technology, Kochi. Other important personalities participating this international conference. My dear students, ladies and gentlemen, International Conference on Statistics for the 21st century is a recurring international seminar conference organized from the Department of Statistics, University of Kerala. You see, statistics is a science which provides the logical system of many other disciplines of science, like biology, agriculture, veterinary science, and even health science experiments. So as statistics progress, the scientific system of a nation progress. This Department of Statistics is wonderfully doing works to develop the statistics through conferences, through researches carried out in the Department of Statistics, with the remarkable results coming out from the researchers, and so on. Moreover, you all know that man is a social animal. Prosperity of man occurs when the prosperity of the community he lives prospers. So likewise, in statistics field also, organizing conferences, organizing symposiums, organizing seminars, organizing workshops, etc., make the statistics profession prosper. And it is not a prosperity to stay alone. It is dynamic. It thereby helps to prosper the community or society as a whole. Because when statistics prosper, other sciences prosper, the scientific system prospers, and welfare of the society is much increased. So, in that sense, the Department of Statistics is wonderfully playing a crucial role in recently organizing several conferences, workshops, symposia, seminars, etc. So this conference is also a part of that action plan. On this occasion, I congratulate the organizers, especially Dr. C. Sadish Kumar and the Department of Statistics for wonderfully involving with this human activity for the prosperity of the society as a whole. I congratulate all participants of this international seminar and let you have uh, a good menu through the academic deliberations of this conference. I wish that you will enjoy with the academic menu provided through this international seminar. Have a nice time. Best wishes. Thank you.
Thank you, sir. Now I request Professor PG Shankaran, sir, former VC, former Controller of Examination, and former HOD CUSAT, to please say a few words.
Professor A. Matai, Professor M. A. Uman, Professor Sadish Kumar, Professor Manoj Chako, and other distinguished participants, resource persons, and my dear friends. At the outset, I congratulate Department of Statistics, in particular, Dr. Sadish Kumar, for arranging this conference involving a lot of renowned statisticians from different parts of the world. The theme of the conference is very relevant in the sense that statistics for 21st century. It's important in the sense that this subject has lot of opportunities as well as lot of challenges in the present scenario. The development of statistics is basically done from the various tools of mathematical sciences, or in particular in mathematics, including linear algebra, vector space, and analysis and other things. But nowadays, this is hijacked, or trying to hijack with the computer science people, in the sense that the software can predict anything using some data manipulation or data computation. But that is not true. So the many tools developed by computer science which are useful for statisticians, like machine learning and deep learning and artificial intelligence, etc. At the same time, we should know the basics of statistics. And people, they are thinking that the statistics means simply the average of something, or calculating some variability of data, etc. But that's not true. As mentioned by earlier speakers, this is a basis of development of many disciplines. So we have a lot of challenges right now across the globe for the growth of the subject, and in particular in Kerala. We also have some challenges because we are introducing the 4-year undergraduate program in colleges and universities, and the statistics has to be a pivotal subject in the curriculum. Otherwise, this subject will be neglected. This will be hijacked by other people. They will misuse this subject without proper knowledge. So my sincere request to all of you to understand the challenges and opportunities of this subject, and aware that this subject we should understand or acquire the basics of statistics very well, and we should use this subject with the help of other subjects like mathematics or computer science, but we should be thorough on this subject. I wish the very best to the program. Thank you.
Thank you, sir. We are reaching the end of the inaugural session, and the happy moments are here. We are going to declare the awards. Actually, not declaration. We are giving out the certificates and cash prizes for the various awards that was conducted during the year 2023-24. The first award is the Professor A. Mathai Best Thesis Award 2023, and it goes to Dr. Jito Jones, University of Kerala. I request Jito Jones to please come over to the stage, and I request Mathai sir to please hand over the award. Thank you. Actually, Jito, please stay. He has got one more award, which is the Professor T.S.K. Mutad Young Statistician Award. So I request Matai sir to please hand this also. Thank you, sir, and congratulations, Jitto. Now, it is we are giving off the award and cash prize as well as the gold medal. The Professor C.R. Rao and Bhargavi Rao Gold Medal 2024, which goes to the first rank holder in MSc Statistics each year. And this year's award goes to Teresa Thomas. I request Teresa Thomas to please come on the stage. I request Woman sir to please hand over the award and the medal. Thank you, sir, and congratulations, Teresa. ഇനി വന്നേ നിങ്ങൾ നിന്ന് കുരുക്കഴിച്ച് കൈ കൊടുത്താലും മതി അതെ അതെ അല്ല പക്ഷെ ഇറ്റ്സ് ഓൾ ടൈഡ് അപ്പ് ടുഗെദർ. So the next is Professor Kalyanaraman. There are 3 awards in the name of Professor Kalyanaraman: the gold medal, the silver medal, as well as the bronze medal. It comes with a certificate of merit, cash prize, as well as a medal. So the first prize, the gold medal, Professor K. Kalyanaraman gold medal, goes to the first rank holder in MSc Applied Statistics and Data Analytics, and this year's award goes to Hisham Ahmed. I request Woman sir to please hand over. They have got a gold medal also, but sorry. Thank you, sir, and congratulations, Hisham Ahmed. Thank you. The next is Professor Kalyanaraman silver medal, which goes to the second rank holder, and the second rank holder is Vidyanjali VA. Vidyanjali, please come to the stage. I request Yagin Thomas sir to please hand over the award. Thank you, sir, and congratulations, Vidyanjali. The next is the Professor K. Kalyanaraman Bronze Medal Award, and I request Shankaran sir to please hand over the award to Megha M.R. Bronze Medal. Congratulations, Megha, and thank you, sir. The next award is Professor R.N. Pillai Best Project Presentation Award, and it goes to Ms. Anjali A.B. Nair. Anjali, please come to the stage. I request Shankaran sir to please hand over the award. It's actually sir. There is one more award to Dr. Jitto Jose. Professor P.S.J. Nair Best Paper Presentation Award. Jitto Jose, please come on the stage. I request Matai sir to please hand over. Riya se arige taro? Alla, certificates. We have got more awards to give away, but I don't know. I'm not sure whether the participants are available here. These are the awards that were conducted in association with the various conferences, the Best Paper Awards, conducted in connection with ICSTC and WSTA. I'll just read out the names. Professor C.R. Rao Best Paper Presentation Award, Dr. Santosh Shashikant Sutur, University, Shivaji University. The next award is the Professor Eliama George Best Paper Presentation Award to Mr. Sri Vallabha S, Department of Statistics, Bangalore University. The next award is Professor Jacob Sundaraja Best Paper Presentation Award to Ms. Benita Susan Anian, Madras Christian College. Then it's a Professor P.C. Mehalnobis Best Paper Presentation Award 2024 to Dr. Kumar M, University of Delhi, New Delhi. Professor R.N. Pillai Best Paper Presentation Award again to Mr. Shubham Nibhalkar, Indian Institute of Technology, Mumbai. The Professor R. Krishna Pillai Best Paper Presentation Award to Ms. Sini KP, St. Thomas College, Thrissur. Professor Jacob Sundaraja Best Paper Presentation Award in association with ICSTC 2023 to Ms. Benita Susan Anian. Then Professor U.S. Nair Best Paper Presentation Award, association with ICSTC 2023 to Ms. Ashwati S, Cochin University of Science and Technology, and Professor KCS Pillai Best Paper Presentation Award 2024 to Ms. Fatima Jeffna, University of Kerala. None of the awardees are present here, so we're just announcing. There is one more announcement to be make, which is the announcement of Professor A. Matai, Best Thesis Award winner for the year 2024. I request Professor P.G. Romeo, former Professor and Head, Department of Mathematics, Cochin University of Science and Technology, to please make the announcement.
I am happy to announce that the evaluation committee informed that the best PhD thesis award will go to Benoth Meeranna from Banaras Hindu University, and this award is instituted on the name of Professor A. Matai, and this will be distributed next ICS conference. This will be distributed in the next conference, and it is instituted by Mathematical and Statistical Science Trust Kerala from next year onwards. This year it is by Department of Statistics. Okay, we congratulate Banath Jivanna for his outstanding achievements.
Thank you, dear Professor. We are reaching the end of today's inaugural session. I request Dr. A. Riaz, the organizing secretary, to please say a few words in gratitude.
Good morning, everyone. It is my duty to express my sincere thanks to all the distinguished personalities present here. So I express my sincere gratitude to all the chief guests of today's programs and my dear students and Shubha Teacher Secretary, International Statistical Fraternity, and the faculty from the Department of Mathematics. Once again, thank you all.
Thank you. So we have reached the official end of the inaugural session. It's time for tea break. Actually, we are running a little short of time, so I request all the participants to have a very short tea break and be back in the same hall for the technical sessions. Thank you all. We really hope that you have an intellectual, wonderful time these coming few days. Thank you.
ഒരേ സ്പീക്കർ വെച്ച്
മത്തായിസാറിന്റെ ടോക്ക് അത് ചെയ്തോ? അതെ അത് കഴിഞ്ഞ് എന്ത് ചെയ്യാം? അതിന്റെ ഇത് വേണ്ടേ ശങ്കരൻ കേരള യൂണിവേഴ്സിറ്റിയിലൊക്കെ കൂടെ അടുത്ത് തന്നെയാണല്ലോ സുഖമായിട്ട് എപ്പോഴും കാണാം. ഞാൻ അതിന്റെ മുമ്പിൽ കൂടി എല്ലാ ദിവസവും പോണേ വീട്ടിന്റെ മുമ്പിൽ കൂടിയാ. ഞാനിപ്പോ ഇവിടുന്ന് മോള് യൂസ് അവിടെ അങ്ങ് പോയായിരുന്നു ഞാൻ വൈകുന്നേരം ശങ്കരൻ ഓപ്പൺ ചെയ്യുന്നു. അതെ ഹലോ ഫസ്റ്റ് ഇയേഴ്സ് ആണോ? ശരി സാർ ഈ കഴിഞ്ഞ നല്ല റിട്ടയർ ആയി. സാർ ഫോമർ വൈസ് ചാൻസലർ ആയിരുന്നു. അതിന് മുന്നേ കൺട്രോളർ എക്സാമിനേഷൻ ആയിരുന്നു. അതിന് മുന്നണി HOD ആയിരുന്നു. എനിക്കറിയാം.
ഒരു ടോക്ക് ഇതിനകത്ത് ലോഡ് ചെയ്യാനുണ്ട്. ഇത് ഇപ്പോഴത്തേതല്ല, നെക്സ്റ്റ് എന്തോ അല്ലല്ല, ഇനിയുള്ള 2 ടോക്ക് ഓഫ്ലൈൻ ഇവിടെ തന്നെ ഉണ്ട്, 2 പേര്. ഈ മത്തായി സാറ് ഇപ്പൊ പ്രസന്റ് ചെയ്യും. വീട്ടിലായിരിക്കും. ഇതൊന്ന് പ്ലേ ചെയ്താൽ മതി. ഈ ലാപ്ടോപ്പ് അല്ല, ഇപ്പൊ അതല്ല, ഡിസ്ക്ടോപ്പ് ഇതാണ്. മത്തായി സാർ എന്താണ് നീ പ്രസന്റ് ചെയ്തേക്കുന്നത്? ഇനി അടുത്ത ശങ്കരൻസിന്റെ
അതിന് പ്രസന്റ് ചെയ്ത് നമുക്ക് കട്ട് ചെയ്യും. ഫുൾ സ്ക്രീൻ ഇപ്പൊ കുറച്ച് കുറയ്ക്കാൻ നോക്കി. ഓപ്പൺ ചെയ്ത് നോക്കിയല്ലേ?
Welcome all to the 10th International Conference on Statistics for the 21st Century. Now, we are moving on to the first technical session of ICSTS 2024, which is a keynote session that shall be chaired by Dr. P.G. Shankaran. Dr. P.G. Shankaran is the former Vice Chancellor of Cochin University of Science and Technology. With several years of experience in teaching and research, he has served as the head of the Department of Statistics and director of the Center for Population Studies at CUSAT. He has received prestigious awards including the Boycast Fellowship from the Department of Science and Technology, the Young Researcher Award from the International Indian Statistical Institution, and the Distinguished Statistician Award from the Indian Society for Probability and Statistics in 2020. So it is with great pleasure and honor I cordially invite you, Professor, to chair the session.
Good morning. This first technical session will be starting with a keynote speech by Professor A.M. Matai, who is talking on multivariate models through optimization of Matai's entropy. A detailed bio of Professor A.M. Matai is already announced by Dr. Shubha here. So I'm not going to repeat that one. He is a very well-known mathematical statistician, and he has a lot of international exposure, and he's a member of several committees, several professional organizations, and he wrote more than 30 books and 300 articles in internationally reputed journals. So he's basically a theoretical statistician, and his works has applications in different fields, including physics, astrophysics, thermodynamics, and other areas. I request Professor Matai to deliver the talk. This is a 40 minutes talk, so I request him to deliver.
Thank you. Today, I'm going to talk about a little bit about information theory. I got interested into the area in the 1960s, before your parents were born, early 1960s, and then by early 1970s, we had looked into characterizations of information measures and characterizations of our unique determination or an axiomatic definition for some statistical concepts. We wrote up all our work until then, and it was published as the first book in information theory, Characterizations of Information Measures. That was 1975 book. Okay, that's available. So their original measure for information was a measure for measuring uncertainty in a scheme. That means a set of you have events and the corresponding probabilities. So that is a system, and an information, a measure for uncertainty in the scheme. In that scheme means a set of mutually exclusive and totally exhaustive events and the corresponding probabilities. In other words, we have a discrete distribution there. For a discrete distribution, you can construct a measure of uncertainty through a set of axioms. So this was the original measure of uncertainty introduced by Shannon. And then this measure was generalized in different directions. One set of generalization is called alpha generalized entropies. Alpha generalized entropies as well as the original entropy measure were characterized by us, myself and my co-worker, Dr. P.N. Rathi. And then later on, I had introduced a measure for a general structure, not only for discrete distributions or the corresponding continuous density models, or I define a general item for a density. A density as a real valued scalar function where the argument can be anything, like it may be a scalar variable, vector variable or matrix variable, or a sequence of matrices. The conditions imposed on the function are: 1, it's a real valued scalar function, non-negative, and the total integral over it is 1. And for that, I have introduced a measure of entropy or information measure, and we are going to talk about those. It's a function or is an entropy evaluation normalizing 112. So I will go into matrix variate cases, scalar cases, matrix cases, sequences of matrices in the real domain, in the complex domain, and connected materials. Some general logistic type models and all that. So it's based on the optimization of an information measure that I introduced. And this is the original Shannon entropy for the continuous case. Original one is for a discrete distribution. The corresponding for a continuous case or a density is this is Shannon information, fx, ln, fx, log fx, fx integrated. It is derived through a set of axioms. And that was generalized, one set of generalization called alpha generalized entropies. This is the expression, the corresponding continuous case. Original one is for the discrete case. This is the corresponding continuous case, that the density function raised to some parameter alpha integrated minus 1 divided by 2 raised to, this 2 is coming because originally the system was developed for binary systems in computer and other applications. That's why a 2 is coming. Okay. And this rewrote in a slightly different way. And this, well, of course, when alpha goes to 1 in that H alpha, we get Shannon's measure. Therefore, you can call that a alpha generalized entropy because you have the original measure. I introduced, before that I should mention one point, that is this one here. This was introduced by a couple of Hungarian mathematicians. It's called, well, I haven't given the name here. It's a Hungarian group. This is slightly modified. This remains the same, but instead of this like this, take alpha minus 1, alpha not equal to 1. And introduced by Salles in Brazil, and it is known as Salles statistics or Salles entropy. And that one is used to generate a whole area in physics called non-extensive statistical mechanics. So that whole area was built up just based on this particular measure, where instead of 2 raised to 1 minus alpha minus 1, it was replaced by alpha minus 1. That is the only change. So everything is the same. When alpha goes to 1, it goes to Shannon entropy. So it's only another generalization of that. So mine also, you can say that it is a modification of this Charworth Hungarian entropy. I call it H alpha F, and this is the one I introduced. Here this can be interpreted in many different ways. Fx, as I mentioned before, is a very general density, very general, where x can be anything. X can be a p by q matrix in the real domain or in the complex domain, or it can be a sequence of matrices in the real domain or complex domain. X can be a scalar quantity or a vector or whatever it is. When I take a rectangular matrix, that involves a vector as well as scalar quantities in the real or complex domain. The restrictions imposed are real valued function even if X is in the complex domain, real valued function, and then non-negative function, this condition here, in the domain of X, and total integral 1 where dx is defined before, it is this one here. It's a Wedge product of the differentials of distinct real variables in X, whatever is your X. Now, this also we can interpret it as an expected value. If you take this quantity here, instead of 1, this quantity here, then you can interpret it as an expected value of this raised to a minus alpha divided by eta. So a minus alpha I introduced like this. So this is an expected value here as an expected value of this, or which is also the same as an expected value of this whole thing here. And this goes into ln f constant times of that in the limit. So therefore, it's again a alpha generalized entropy of the original Shannon entropy, as well as from a statistical point of view, it is simply an expected value of a certain quantity, a certain power of your density function. And also we can take as an estimate for this quantity here. If you have a logarithmic function coming somewhere in your computations or in your theory, if you want an estimate for that particular factor, you can take this as an estimate for that. We have other uses also. Now the idea is, suppose that I optimize that measure subject to two moments type constraints. One constraint is, suppose that I put the constraint like this: expected value of x raised to some parameter, this is that exponent in the measure, equal to a prefixed number, and second constraint is expected value of that plus delta here in the exponent prefixed. Under these two conditions, where this gamma, delta, eta, they are all parameters, I restrict the delta and eta to be real, gamma can be real or complex. If it is complex, then some conditions real gamma greater than 0 is needed. So if I look into Euler equations corresponding to, if you are using calculus of variation to optimize that measure, then you end up into Euler equation, that is, you differentiate partially with respect to your density function itself. Our density is a functional now, it's an arbitrary function. So f is varying, not the argument. Argument is fixed. Argument goes into a character or like a parameter, and f is the one varying. So you differentiate with respect to f, and this is the actual quantity. This is coming from your first constraint. This is coming from your second constraint, and that this was your original function. This one is your original function. So when you differentiate, equate to 0, solve all this, you finally end up with f is equal to this one here. This type of a structure is coming. In the real scalar case, this is the scalar variable. X is a scalar variable here. In the real scalar case, this is the structure. Now, if I take, we want this to be a density, we want to be density satisfying the previous conditions. So far in coming up to here, I did not use the conditions of a density. Now I put the conditions for a density here. I can rearrange and then get into three different forms of the density from there. This is one form that you can get. This is, you can call it a generalized type 1 beta model. Generalized type 1 beta model. So this part here is not 1, and then delta 1, gamma can be there. So that will be a type 1 beta model. So this is a generalized type 1 beta model. And if I take A, this is for alpha less than A. If I take alpha greater than A, the same model switches into this. That is a generalized type 2 beta model. And if I take alpha goes to A, then it goes into this, which is a generalized gamma model. So all the three families of functions are there in that particular model, previous model. In other words, this is my pathway family of, from what you are going to get is, through that optimization you get this, which is my pathway family for real scalar positive variables. Original pathway model was introduced in 2005 in a journal, in an article in a Linear Algebra and Applications, and that was for a rectangular matrix variate case. The same thing if you take it for a real scalar variable, positive variable, and then this is the one. This is the one you will get. I can modify the moment conditions, and I can get extend it for absolute value of x. In other words, I can extend it over the real line. There is no problem. And I can also extend this to matrix variate cases, and replacing this by determinants and all that, then you will end up into functions of matrix arguments as well as the corresponding distributions of matrix variate distributions. Okay, so that's a line in which I'm going to go. So that's all the pathway families are given there. Some details about that. And there is in physics also, in non-extensive statistical mechanics, this is highly statistics I mentioned before. This is simply a slight modification of the original Hungarian alpha generalized entropy. And from there, you have a whole area of non-extensive statistical mechanics coming, Sally's entropy and the area. Then the Britishers introduced something called super statistics. Again, there is a huge area there, huge development with lots and lots of papers. But you can see that this super statistics is nothing but a particular case of the pathway model that I have mentioned before. And this works only for two situations. In the previous case, I had alpha greater than A, alpha less than A, and alpha going to A. Three situations. Here it only works for the type 2 beta form and the gamma form. For type 1 beta form, this does not work because it is derived from another principle, Bayesian principle actually. If you have a prior distribution which is generalized gamma, and if one of the parameters has a distribution of its own, again a generalized gamma, then the unconditional distribution will be this. In terms of statistical language, the unconditional distribution is your super statistics. Okay. So therefore, when you are dealing with gamma and generalized gamma and then coming to unconditional distribution, you cannot have the type 1 beta form coming there. Type 1 beta form. That factor has to be remain positive. All the parts must remain positive. So that is a major defect. So I have mentioned these aspects here. So now I'm going to go into the matrix cases. This is the notation that we are going to use. Vector matrix variables, mathematical variable or random variables. I won't make any distinction between mathematical variables and random variables. In fact, there is no need for making a distinction between the two. Mathematical variable will be interpreted as degenerate random variable. That's all. I need only one definition. So in this notation, this small letters A, B, etc. will be, the constants will be denoted by this, vector matrix constant will be denoted by this, variables in the complex domain, in order to distinguish variables in the real domain and variables in the complex domain, I will use a tilde for variables in the complex domain. So that whenever an expression comes with the tilde there, that corresponds to complex domain results. And this is another quantity that I need. This star means conjugate transpose of that matrix, conjugate transpose. Okay, that star will be used. Now, if you have a matrix, a square matrix, and is equal to its conjugated transpose, then this is a Hermitian matrix, Hermitian. And this notation means positive definiteness. Matrix greater than a null quantity or a big O means positive definite. So this means X is Hermitian and positive definite. Positive definite means it has many properties. One property is that all its eigenvalues will be positive. In the Hermitian case, the eigenvalues will be real. In the real case, of course, eigenvalues will be real or complex. In the Hermitian case, eigenvalues will be real. We can prove. And therefore, they can be real positive or real 0 or negative. Okay. So, this notation also I may use once in a while. This notation means they are all P by P square positive definite matrices. Square positive definite matrices. This means A is positive definite, X is positive definite, B is positive definite, X minus A is positive definite, B minus X is positive definite. So that's a notation under those conditions. Corresponding notations, and I will use this notation also. When the elements are in the complex domain, and if you compute a determinant of a matrix, a P by P matrix, then that determinant will be simply a scalar variable, complex variable with something like A plus IB, where A and B will be real scalar quantities, I is square root of -1. So therefore, if I take the absolute value of this means A squared plus B squared square root of that. That's the absolute value. So this is the notation that I will use when I talk about the absolute value. There is some general properties here. X prime means the transpose of X. If X's are all distinct random variables or mathematical variables, this quantity is simply the sum of squares. The corresponding X star X, that means conjugated transpose times X, will be sum of squares of the absolute values. That means instead of P sum of squares here, you have 2P sum of squares there in the corresponding complex case. So therefore, I need to develop only the theory for real cases. I can handle the corresponding theory for complex cases by small changes here and there. So if vectors are involved, this is the connection. So I need to, if I have P in the real case, then 2P will be corresponding quantity in the complex case for the vector. Similarly, for the matrix, I can show the connection. Now, when I have distributions connected with X prime X, such a distribution, this is a particular case of, if I talk about a distribution involving this, involving S prime X, a function involving S prime X, which is a density. Such a density is usually called the spherically symmetric density. Spherically symmetric density. In other words, this is a sphere here. This equal to a positive number is a sphere in the real domain. in the Euclidean p-dimensional Euclidean space. Now, if I have this thing here, this equal to a constant, positive constant, simply means either a p-dimensional sphere in the complex domain or a 2p dimensional sphere in the real domain. That is the interpretation. Now, another interpretation in terms of geometrical probabilities and all that is that this quantity is invariant. Okay? Invariant under a rotation of the axis. Or in other words, in linear algebra language, if you look into orthonormal transformations, that remains the same. Whatever be your orthonormal transformations, that quantity will remain the same. Okay? That is rotation invariant as far as geometry is concerned. And we have slightly more general measure there, location as well as rotation invariant. In other words, if you displace something to some other place, your measure, probability measure over that should not remain, it should not be changing. It should not depend upon where it is located. Okay? Even if you remove it from there, the measure imposed on that particular object should remain the same. It's called invariance property. That we will need later on, if you want to connect it to geometrical probability problems. Otherwise, it's okay. Because what I discuss is having connections to various different disciplines. This is simply not only just statistics. Okay? It has connection to all types of, a large number of disciplines. So again, in terms of expected values, I optimize here. Previous condition was something like, now this is a multivariate case. In the multivariate case, corresponding final result will be like this. You have this sum of squares coming, instead of a scalar quantity, you have sum of squares coming. Now this is of the form x prime x raised to gamma, x prime x raised to delta, that type of thing. That's a corresponding multivariate case. This is associated with this particular format is associated with type 1 beta distributed random points in a p-dimensional Euclidean space. That is random points in p-dimensional Euclidean space. So that is this is just as I mentioned here, written in terms of x prime x. This structure here is now I can generalize to any type of functions of matrix argument. Instead of a vector there, I can now replace it with a p-variate. I can this is vector case. I can replace it with a p by p or p by q matrix. That is the one I will consider next. So for transformation purposes, I need a small result on Jacobians. Like if you have something like this, x prime equal to s. Remember that this is the same, this structure here, if it's a p by q matrix, that structure can always be interpreted in terms of a sample matrix. Because nowadays, when you have a satellite data coming, a satellite can observe millions of variables at the same time. So that means you have, say, one vector of length 1 million, vector of order 1 million. When that observation is repeated over time, what you are having is a number of observations on the same variables. So finally, you are getting a p by q type matrix or a p by n type matrix, where n is bigger than or equal to p. If you have more observations than the number of, than the dimensional number. So that is equivalent to, in terms of statistical literature, that is having the same structure as a sample matrix when you are taking a simple random sample from any population, p-dimensional population, where p can be a small number or a large number. So there the relevance comes in. Asymptotic distributions when the dimension itself becomes large or go into infinity. Then of course and the sample size also will go to infinity. That area is now developing fast when in connection with large data analysis in data science. And I have plenty of results in that. I will come to that later. So there, when you are making the transformation, x prime equal to s, we need a Jacobian connecting to these, connecting the differential element of s and differential element of x. That connection can be established, and this is the connection. In the real case, the determinant of s will come. Q is bigger than or equal to P, and we have taken the P linearly independent, the rows are linearly independent, and Q is bigger than or equal to P. In other words, the rank of this matrix is assumed to be P. Then x prime will be a positive definite matrix. X prime x will be a positive semi-definite matrix. Both will come in our discussions. X prime will come when we talk about non-singular distributions. X prime x will come when we talk, x prime will come when we talk about singular distributions, corresponding singular distributions. So this is non-singular distribution. So the connection is dx, differential element of x is connected to differential element of s through this relationship. And that is available in my, that was old result, available in my 1997 book on Jacobians. And the corresponding result in the complex domain is this. Note that in the real domain it was pq by 2, now it is pq only. Here it is a gamma function in the complex domain or complex matrix variate gamma. This is, instead of determinant, I have the absolute value, the determinant remaining. So those are the changes in the complex domain. And this is the gamma, matrix variate gamma in the complex domain. So the expression is different. In the real case, it will be p into p minus 1 by 4. Here alpha minus 1 by 2, alpha minus 1, like that, alpha minus p minus 1 by 2. But in the complex case, two such things are coming and joining, and you get, in fact, if you look into the analysis, mathematical analysis of the statistical problems in the complex domain is simpler than the problems on the real domain. Okay. So if you have real domain results already, or you know the real domain literature, then going into complex domain is very simple, very easy. This is the corresponding. If you have a 1 by particular case, 1 by n, 1 by p case, 1 by p case, the connection will become like this. For evaluating the normalizing constant, some computations, you may not be interested in that. These are the normalizing constant in the type 1 case, type 2 case, and a type gamma case. This is the gamma case. The previous one, type 1 case here, type 2 case here, conditions are here, conditions are here, and gamma case here, conditions are here. Okay, not relevant. Yeah, multivariate densities in the complex domain, optimizing my own entropy. As I mentioned before, here you have only, here you have 2p variables. You go through the same process, and these are the moments, restrictions, same pattern. Only difference is this, u is different. That is the only difference. Same pattern. And here I use this property before they mentioned already. You end up like this, and you can be So here I have again three different situations. The F1 will be like this. It is a generalized type 1 beta type model. Now here U, as you can see before, U can be either a scalar quantity or sum of squares of the quantities like that, or even a by like elliptical type of thing can come, quadratic form can come. Okay. The corresponding complex case, that is one simple problem you can look into is if U is trace of U prime. When you have X, whatever be your X, trace of X prime will be simply sum of squares of all elements in that matrix. Trace of any matrix. You take any matrix, P by Q matrix, and times its transpose, or transpose times that matrix, both. Trace will be the same for both, and trace will be simply sum of squares of all the elements in that matrix in the real case, and in the complex case it will be sum of squares of the absolute values of the elements. So those properties will be used. So these are the restrictions or the constraints. And under the constraints, if you go through the same process, same steps, we end up with this. You can see that the structure remains the same, that U is now trace of X prime. Now the result is again the same type of two families of functions. So one family I already mentioned there. This is the second family, type 2 beta type family. This is the third family, the gamma type family. There, here it is a trace of X prime, the trace of X prime. So by, you can tell me when to stop. How many? 5 more minutes, no problem. Again, some distributions involving determinants depends upon the here the restrictions. I put determinant of X prime raised to something. This is what we call the generalized variance according to anyhow somebody defined it as generalized variance. It is not, but anyhow determinant of a X prime type matrix. Okay. And I put the conditions on the determinants. Two types of conditions on the determinant. One is this first condition is just on the determinant. Second condition is on the determinant and the trace. Then you will get an interesting distribution. So you get the limiting part is the most interesting part. So this is the type 1 beta form, determinant raised to, then here trace raised to something. So three types you will get for three types. Here if I change the conditions like this and conditions like that, you will get a very general type of density. In other words, all types of densities can be generated by simply optimizing that measure of entropy subject to certain types of restrictions, conditions. Depending upon the conditions that you impose, you can end up with the various types of results. Those are, this is one type here. Here trace raised to something, trace raised to something. Here sum of squares, you can sum of squares of the absolute values raised to rho. Here sum of squares of the absolute values raised to something. You can say that a generalized gamma type distribution, or a generalized Gaussian type distribution. When gamma equal to 0, it's a Gaussian type. Otherwise, it is a gamma type. So you have more restrictions, more structures. So all types of structures are available. I also look into general multivariate logistic type models. So I also look into various types of logistic models and generalizations of those. That also, all those you can obtain through this same technique. So that is the material. And these are the paper on super statistics. This is the paper on Sally statistics. From 1988, he published it and created non-extensive statistical mechanics. And by 2000, there were over 5,000 articles published in that area, over 5,000. And similarly, on super statistics also, over 1,000 maybe articles are there. And this is the book I mentioned, the first book on characterizations of information measures, Wiley, Eastern and Wiley, New York publication. That's the first book in the area. Similarly, that I did not mention geometrical probability book. That's again first book in the area, and 1996 book. So that's all. That's all what I would like to say.
Any questions or clarifications you record? You have studied the distribution theory, so you see that how this univariate or single variable is extended to multivariable matrix theory and complex theory. So
All these are very simple and
direct.
extensible and interesting applications in all different areas. You look into the structures in various areas, you will find basically statistical things can be applied and developed.
Okay, one this thing. So I have read that Kapoor's basic book on information theory, Professor Kapoor, and I saw some of the ideas in your book also.
Yeah.
So this, like this, we can extend other information measures to this setup, means metrics and complex variate. So same idea can be extended.
Same thing. Same thing.
So we will get different types of distributions that way.
Yeah, I just put a measure which is valid for scalar variable case, vector case, matrix case in the real and complex domain.
My question is, there are a lot of information measures, including UIs.
Different types.
Different types. Okay.
This is alpha, one category called alpha generalized entropies. That family.
Okay. Okay. Once again, we thank Professor M. Matai for his informative talk on information theory. Thank you. Thank you, sir.
Now I welcome Dr. P.G. Shankaran to hand over a token of love to our Honorable Speaker, Professor A.M. Mattai. Now I welcome Dr. C. Satish Kumar to present a memento to Dr. P.G. Shankaran as a token of appreciation.
Thank you, sir. On behalf of the organizing committee of ICSTC 2024, I am deeply honored to extend our heartfelt gratitude to Professor P.G. Shankaran for chairing this enlightening session on multivariate models through optimization of Mathai entropy, presented by distinguished Professor A. Mathai. We deeply appreciate the time and effort you devoted to facilitating this session. I would also like to take a moment to thank Professor Mathai for his presence as a mentor, shaping the path for generations of statisticians, including those of us who are still in the early stages of our career. Once again, thank you. We look forward to your continued guidance and support. Now, for the second technical session of ICSTC 2024, I invite Professor Yagin Thomas as the chair. Professor Yagin Thomas is a distinguished academic and former HOD of Department of Statistics, University of Kerala, who is specializing in order statistics, statistical modeling, and applied probability. He was granted the Emeritus Scientist by the Kerala State Council for Science, Technology, and Environment from 2016 to 2019 and Professor Emeritus in 2013. He has contributed significantly to advancing statistical methodologies and their applications in diverse fields. He has also authored numerous research papers in leading statistical journals and actively collaborates on interdisciplinary projects. Dr. Yagin Thomas has always been a man of distinct vision and a constant source of support in all our events. So, it is with great pleasure I invite you, sir, to chair this session. Over to you, sir.
Greetings to you all. We are next passing on to the next technical session, session number 2, and we are very lucky to have Professor P.G. Shankaran, the former Vice Chancellor of Cochin University of Science and Technology. He is both good in academic matters as well as in administrative matters. So we are lucky to hear him in this session. He will be talking on proportional hazards regression for zero inflated cure rate models, an application of cervical cancer data. So Professor P.G. Shankaran, kindly. You will have 35 minutes. So,
So topic of today's presentation is basically a semi-parametric regression model for the analysis of a specific type of survival data. As you know, in survival analysis or survival studies, the variable of interest is time to occurrence of an event. Generally, it may be death of a patient or time to occurrence of a certain disease or the recurrence time, some recurrence time between two events, etc. So basically, this is a and time to occurrence of an event. Then we know that if you measure the time to event of interest t, in addition to this time, it generally we call it as a lifetime. We have some related information associated with each subject. It may be the disease status or the gender or the age of the patient or some other variable like type of the treatment, type of tumor or some other. So our objective is to know the or understand the relationship between this lifetime variable and the associated variable. We generally referred this as covariate in survival analysis terminology. So basically you try to use this relationship to know the effect of these covariate into the lifetime. This is a different from standard regression analysis where you can have the model like y equal to x beta plus epsilon, where y is the response variable and x is the exploratory variable. You can use other theories like epsilon follows Gaussian distribution and some other assumptions. You will get easily the estimator of beta. Here the problem is basically the lifetime variable is non-negative variable which can be transformed into a real variable by taking log t or some other way, or the other problem is we face some type of speciality in survival studies like censoring and truncation. So what we considered here is a different types of regression model where you can have the impact of these variables on lifetime by specifying certain functional forms, for example, Cox proportional hazards model or accelerated time model or proportional odds model. So what we are going to consider here is a proportional hazard model, which we generally referred as a multiplicative hazard model, and it is one of the semi-parametric regression model. Now coming to this speciality of this, what we do is this is Cox proportional hazards model. It has a lot of application in different fields. It was established in long back 1975 in a paper in JRSS, Journal of Royal Statistical Society, and one of the papers or mostly cited by different authors. So what we do here is a different type of data. Instead of considering recurrent data or usual survival time data, we have some peculiarity on the data structure. One thing is, if you consider an epidemiological study, you can see that some of the individual, they will not have that particular occurrence of time to occurrence of that event, for example death. So that those type of individuals are not generally censored individual. They might have that particular one type of disease, but it is cured. So these are known as long time survivors or cured individuals. So we have a cure and non-cure type or disease affected individuals and cured individuals plus censored individuals. So three categories. Second part I'm going to consider is one of the different area where in certain cases you will have very early failures, because at the time of measurement itself we can see that there are 5 or 10 individuals have experienced this particular type of event of interest. So that is early failures. So those failures are generally referred as zero inflected keyword data or zero infected survival data. So we are considering two additional things. One is keyword setup, second one is zero inflected early failures, similarly long time failure or long time survivors and early failures. So how to analyze this type of peculiar data, and some methods have already been discussed in literature, mostly by parametric approach. What we are going to consider here is a semi-parametric approach. This is a joint work with my colleague Dr. Sridevi and one of my students. She is working in medical college, government medical college Thrissur, Dr. Rajini. So so I will briefly. So, so I have already mentioned these things. Then, for example, I will take this example. In many clinical trials on cancer patients, a large proportion of individuals survive the disease completely. So these patients cannot be treated as censored and should be considered as cured individuals. So we have cured. Accordingly, there is a branch of survival studies where we can consider modeling of this such a type of data which is can be used using which can be done using these cure rate models. So the entire population is divided into two group of individual, susceptible and non-susceptible, or cured and non-cured. So the usual procedure for modeling this type of data was established long back by which is known as mixture model, and there are other works known as non-mixture model. The mixture model was introduced by these two authors in 1952, long back, where the survival function of the T that can be written as P1 plus 1 minus P1 into S of T, S naught of T, where P1 is the proportion of cured individuals and the remaining individuals 1 minus P1, you will have the survival function of uncured individuals survival function. So this can be generally referred as mixture model. There are a lot of works on mixture models by several authors, including the latest work using data science technique such as machine learning and nonlinear pattern recognition. So these are the recent work on this topic. Now, in addition to it is observed that a proportion of study subject may experience the event of interest even at the beginning of study. These lifetimes should be considered as early failures and treated separately. If you are not treating separately as they are taking as lifetimes, then what we will get is the model which you are going to get will be overestimated. So early failures are recently referred to as zero inflected lifetimes in survival study. So to handle zero inflected lifetimes in survival data, one has to use zero inflated lifetime models. So zero inflated lifetime models can be easily developed by taking or by changing the parameter space, so that the idea is the probability the survival at a time t that will not be equal to 1. It will be a quantity which is different from 1. S of 0 is not 1. Survival function at 0 is not equal to 1. It will be a quantity which is different from 1. So you can easily get lifetime models which can be used in this context. But I am not going to consider the parametric model in this talk. So this zero inflected lifetime models generally it can be represented by a survival function S of t is equal to 1 minus P naught into S naught t. Here the P naught is the proportion of early failures or zero inflected lifetimes, and 1 minus P naught is which are remaining quantity multiplied by the survival function. So P naught is we treat separately, and 1 minus P naught will be this ST will be actually 1 minus P naught in S naught t, and FT, this density function if you consider is that will be P naught at t equal to 0 and 1 minus P naught into F naught t, that is the difference. So further of this you can see the different researchers worked on this topic. In certain situation we come across zero inflated lifetime data along with the cured data setup. For example, we consider a cervical cancer patients from Brazil, which was discussed by this particular study, Brana et al. 2004. In this data, we could see that some individuals experienced the death due to cancer immediately after the treatment. The corresponding lifetime should be treated as zero inflected lifetimes, and some other patients never experienced the event of interest which ensure the presence of cured individuals. Hence, the data should be analyzed using the method which is different from traditional survival analysis technique. Then the applications of zero inflected cure rate models. There are different approaches. One is promotion cure rate model, or mixture cure rate model, or Weibull regression model, etc. There are a lot of works in this, and even Bayesian setup also. One work was done in 2022 by these authors. All the above works, they use parametric approach for the analysis of zero inflected cure rate model. But we know that in some certain situation, because of censoring and other conditions, it is very difficult to identify the appropriate parametric model. So in survival studies, we use a semi-parametric model in such context, like proportional hazards model or isolated lifetime models, etc. In this, there exists only a sparse amount of literature on semi-parametric or non-parametric analysis of zero inflected cure rate model. What we do here is we present a proportional hazard regression model for zero inflected cure rate model. So this is a BIG. So suppose that the population consists of two groups of subject, the susceptible group and cured group. Then this y, this is an important quantity y, which denote the indicator variable takes value 1 for this particular group, uncured group, and 0 for cured group. So you can get a binary random variable. Then Z, as usual, is a set of covariate d by 1 vector of covariate, and then we assume that in certain cases you can have different set of covariate for cured, zero inflected, and even effect of covariate on lifetime t also. But we, for time being, we consider the same set of covariate by Z, that is a d by 1 vector. You can assume that this is a common covariate which can influence on zero inflected case and cured case as well as the lifetime. Okay. So the P1 Z, basically P1 Z is probability of y equal to 0, that is y equal to 0 means that is cured group, that is P1. P1 is basically cure rate. So one of the problems in this context is estimate this cure rate. So P1, so that we are going to consider, which given is a then TB, as usual, a non-negative random variable representing the lifetime or time to occurrence of an event when y equal to 1. Y equal to 1 means in this case that is for susceptible group, that is non-cured group. Then assume that there exists a fraction of individuals who experience the event of interest in the beginning of study, that is early failures. So the P naught Z be the proportion of those individuals. Here also this covariate that influences these early failures also. So that is, and we have these conditions of the usual, these are the probabilities also, and the survival function for the susceptible group, that will be the S naught of t given y equal to 1, that is probability of t greater than or equal to t. Then the survival function of the entire group, that is the zero inflected cure rate group, is ST given Z is, we have P1 Z, that is this cured group, plus 1 minus this P naught Z, that is early failures, minus P1 Z, that is cured group, multiplied by this quantity. So this is a extension of a mixture model. In addition to cured and uncured, we will have the other quantity, which is the zero inflected group also. Okay, so this is our model. Now if you can easily see that the probability of P naught is equal to 0, it reduces to standard mixture model, and P1 is equal to 0, it reduces to the usual zero inflected model. And this case, the earlier one, this S can be written in terms of F also. S is equal to 1 minus f. After some small manipulation, you will get f equal to this, and finally the density, which has two parts. If t equal to 0, you have a positive mass here, and t greater than 0, you have this quantity. So this is a. Now the rest of the analysis is simple. I am not going to describe all the things. Quickly I will follow. The idea is we construct the likelihood. You construct the likelihood. Then the thing is that you have certain quantities y equal to 1, that is equal to uncured uncured portions, and y equal to 0 cured portion. So we do not know this value of y in the sensed setup, because there are sensed observations also we do not know. So what we do is we estimate this y again, y equal to 1 for definitely for having lifetimes, observed lifetimes, but there are observation which are censored. For that y equal to value of y is not known. So after constructing the likelihood, what we do is we use EM algorithm, and first step is to find the unobserved YAs. Then you have a step by step estimation, maximization done. A step by step process is done to find out or to maximize the likelihood and find out the MLE in this process. That is the idea. So I am not going to elaborate. I will write the likelihood and the other things. So it can be shown that these things are there. Logistic. Now, before that, before writing likelihood, what we do is, this is a logistic. P naught Z is the probability. So we use the logistic model to find out the unknown quantities P naught and P1, which actually depends on the covariate. So this is a vector B. It's a vector with the regression coefficient associated with the 0 inflected, and vector regression coefficient associated with this corresponding to logistic model. Then under logistic assumptions, we write these P naught Z and P1 Z, and then we use the usual proportional hazards model, that is ST given is given y equal to 1 is S naught t raised to e to the power of beta dash Z. So then FT will be this, you can FT will be lambda into S naught t. So instead of this ST, you can write these things in the likelihood. Next, suppose to find out the estimate, we have n independent and identically observed random variables. We have 4 quantities basically. One is Ti, that is observed lifetime. Another one is delta I, which is an indicator corresponding to the censoring. Delta I equal to 1 if it is a observed one, 0 censored one. Then delta I star, which is equal to 1 when Ti greater than 0, that is and 0 inflected case is Ti equal to 0 and Ti greater than 0. So that those two cases. Then Z is, as mentioned earlier, d by 1 vector. So the data consists of whose lifetimes are 0 inflected, individuals with observed or censored and cured. All these categories are coming. Now you write the likelihood. This is this part for cured, then 0 inflected, here delta star. So this is for 0 inflected, this is for 1 minus delta star equal to 1. So this is for this keyword, and the remaining quantities you can write this is for FT, and this is surviving censoring variable. So censored this part, this is the observed one, this is one keyword, and this is for 0 inflected. So this is the likelihood. Then yi with the observed value of the random variable yi, we assume that if delta I equal to 1, that is not censored, then yi equal to 1, and delta I equal to 0, yi is unobserved. In the censored case, delta I equal to unobserved. So you can write this likelihood is a complete likelihood in this fashion. They substituting yi in the 0 case, you can substitute yi, and you can write this after some simplification, this lambda you can write, this Fe you can represent in terms of lambda. This lambda you can write this, and you can factorize into this complete likelihood into two parts, one involving the Qr part and zero inflected part, P naught and P1 part, the other involving beta, the regression part, and the baseline hazard function part. So this is one part, and this is the remaining part. Then this part, first what we do is we consider this and we estimate YA for censored case. That is the first side. That is the expectation algorithm. YA is missing, so we use that first part, expectation part. Then the next part, so once this is estimated, this pi r, then you substitute instead of YA those values. Individually is uncensored or simply 1, individually censored, you will get this pi r from previous expectation step. Then you use this and then you maximizing the power. For maximizing this, we have a complex situation, so we use a profile likelihood method. So next step is profile likelihood method. So I'm saying maximizing conditional expected of completion log likelihood, data likelihood. Then we substitute B hat and C hat of B and C are obtained by maximizing the first L11. Then you substitute those B hat and C hat, and Wi, this value, you will get this quantity baseline hazard. From baseline hazard, you substitute those values and you will maximize this likelihood, which is nothing but some type of partial likelihood, extension of partial likelihood. You can see that this quantity, this is simply omitted. So they are one, simply one. It is simply the original Cox likelihood proposed in 1975. This quantity is simply 1. That is idea. Okay. Then now maximizing L3, we get the estimate of beta and all these things. To study the asymptotic property of estimator, we obtain some approximation for asymptotic variance of these things, and we can easily prove that this is asymptotically unbiased, and these estimates are asymptotically unbiased, and you can prove the consistency also. Then I am not going to discuss the identifiability problem because a lot of parameters are involved, and you can consider the identifiability problem, and which can be easily handled this case. Now coming to simulation studies, to measure the efficiency of the procedure, we conduct a simulation study. You consider a Weibull distribution. Weibull distribution is a generalized Weibull distribution. The baseline distribution is a Weibull distribution. This is a Weibull distribution. You have e to the power of this. This is. Then we consider the various choice of mu and k used in this. We generate censoring variable from uniform distribution in such a way that 25% of censored observations are in the sample. In certain cases 45% are censored. We consider both 25 and 45. Then we have data, this t z delta star, where t is the minimum of t and c. Then to generate the Weibull t, we need a covariate also. We consider two covariates, one from Bernoulli generated from Bernoulli, other from generated from standard normal, and we have this step-by-step procedure for this. This is an algorithm for generating quantities, and finally you will generate samples of different sizes repeated for 1,000, and we calculate these things. This is a percentage of censoring 2040 sample size, bias of the estimator of beta 1 hat, this beta 2 hat, bias and MSE. This is similarly we find the bias and MSE of these regression coefficient corresponding to logistic model. That's also considered. We see that bias, absolute bias and MSE of the estimates are negligible. We can also note that the absolute bias and MSE decreases as sample size increases. However, absolute bias and MSE increases when censoring percentage increase. We have considered different points and we calculate the estimate these survival probabilities S not T also, that also you estimate. This is then coming to the data I mentioned earlier. We illustrated the applicability of the proposed model with a Brazilian invasive cervical cancer data studied by these two. First, it was studied by this Brana 2004, and later it was studied by these. They use both uses parametric model, but this they use Bayesian approach. That is the difference. Zero inflected data consists of 124 women diagnosed with invasive cervical cancer who have completed standard treatment recommended by the International Federation of Gynecology and Obstetrics, which is collected between 1992 and 2002 in Brazil. The time between the date of surgery and date of death, that is the variable T we take, and disease recurrence status, which is the covariate information, are available.
Good afternoon, all. We are moving to the third technical session of ICSTC 2024, which is a C-level session that shall be chaired by Dr. P.T. Romeo. Dr. P.T. Romeo is a senior professor at the Department of Mathematics, Cochin University of Science and Technology. He is known for his expertise in areas like applied mathematics and mathematical modeling. His contributions include significant research publications and active participation in academic development. As a dedicated educator, he has been instrumental in mentoring students and advancing mathematics research exercise. So with great pleasure and honor, I invite Dr. P.T. Romeo for chair the session. Thank you, Professor.
Good afternoon all and welcome to the third session. Our first speaker will be Ashwin Kumari. He will be talking about aggressive auto moving average models in count data. Please.
1987, and oil in 2000 and 2013 was developed, and 2005 and the land is also done, and 2003 is a book published by the archive platform which is given. So this is mainly focusing on the AR model. So what we have tried to look at is how is it combine models with who's now and the AR model. So in the longitudinal setup, what I talked about the time series component is not that small, really few, but and we have several individually occurring also. So the normal time series, you can say one community only like one stroke or one temperature only one place you are taking, but you know the two setups have different individuals. And those individuals are independent, but if you take one time series per model or depend on that. So here this gang and you point is such a longitudinal setup in the two models. The time series that also look to be over a longer period may not be so, and this paper studies the air model and discusses renewable conditions and here needs to be for the parameters. And I can still propose the MA on the ARMA model, but we will discuss on the combination. So here, what we are trying to do is especially the longitudinal data, we are mainly focusing on the MA1 or differential modeling, and we use the same approach and the distribution with the generalized quasi likelihood approach for estimation of the process. So we are looking at this and I think the basic economy, the system case like one model. So we have tried to develop the basic properties of this technology and also applications for our proposed ALMA 1 model and with the binary offspring and ALMA 1 model with the binary offspring. So the binary offspring means each individual at the time T minus 1 can produce maximum only one. Here in the binomial setting we can go over. There's a difference. So there's a model is different. And we were supposed to compare the AR11 model for the common data and AR11 for the parameters and estimation of the parameters using the possibility and generalized model. And we have the ability to distribute the probability of the parameters. So that is a very important thing. So it is more or less same for all the three situations, but we'll explain more on the binary offspring case. So here, let YT be the total number of individual time t with the specific characteristics of inputs and GP represent the variable indicating the number of individuals entering to the population from different regions at time t. So our proposed automatically moving our model of 1 is YT equal to rho 1 YT minus 1 plus rho 2 star dt minus 1 plus dt. So this is the AR1 process and the star denotes the binomial tuning operation. So the tuning operation may be individual can produce or both the binary or binary. So assuming that an individual can produce either one offspring or none, this equation number can be written yp equal to j equal 1 to yp minus 1 b1 j rho 1 into the binary and the j equal to 1 to bt minus 1 bj rho plus dt and this b1 j is the binary and bt is the binary with parameter 1 is the n, the n is the 1 and rho 1 is the probability and rho 2 is the probability. So this is a binomial property given for the 1 and in this case the assumptions we have is y naught equal to 0, then y1 equal to the points of u1 and d1 equal to the points of u1 U1 and DP equal to Poisson PT minus 1 PT minus 1 output P equal to 2. So this is the model we use that DP and YP are independent for assumption we make. So here, because we are in this case, we want to understand one and this one. So mu t, again the mu t, the mean of attack t, because there is a count data, so we use this the lead function here, exponential of xt beta. So xt's are the covariant information of the t for the individual. Whereas it can be so we have the normal time series is only this for the CV information covariant like any information like individual you have taken which is sex or like that. So any covariant information can be that. So the mean process, the mean of the person must be non-negative here again. So therefore, the rho one should be less than the condition imposed for a fixed value. So the rho two, we need to have this condition to the minus one minus this. And for the stationary case where the covariants are same, then rho one could be simplified to this form. Okay, for the rho one for the fixed values of the rho two, this information is satisfied. Then we can find out derive the basic properties of the alpha model here. So the mean of the yt to expected value of the base versus the dt minus 1 minus 1 and expectation of the yt dt minus 1. So this is the condition on the one is again you can expectation of that you can do double expectation. Again the variance also can be done like the variance of the t can be just like expectation variance and variance specific. So that is the process we do. And the covariance between the yt and yt minus k with the binary offspring can derive this as the covariance of this, with the covariance of this, and the covariance of this. And the correlation between yt and yt minus k can be derived using over here. So using this formula, so we derive the basic properties of the error model. So yt is the number of into the time t and the time t. So the covariance between and we are assuming yt equal to Poisson Vp equal to exponential with the property the covariance between the yt and yt minus k is the rho 1 plus rho 2 times Vp minus 1 minus rho 2 into 1 Vp minus 2 plus rho 2 into P minus 2. So for k equal to 1, then for k greater than 1, we can say rho 1 power k Vp minus 3. So this is the covariance we derive based on this property and the correlation between the yt and k. And this is mainly based on the binomial offspring according to which one can be produced only maximum one also. So the correlation also can be derived using this. Okay. Then the stationary case, when we are seeing a stationary situation, like the covariance can be reduced in this case. In this case, we only like this one. This is stationary case. The correlation is also can be reduced this one. So the earlier one is non-stationary, and P minus is there. But this is in the silver scale, non-stationary. So when k is greater than 1, we obtain the U not exact different situations like the following is only given k equal to 1 times different over k is equal to. So the autocorrelation function for the Poisson alpha 1 model says that the autocorrelation function of the AR1 model of the NAM1. So that is the so hence k greater than 1 alpha 1 model for the Poisson giving like close to this model. So similarly, the autocorrelation function of AR1 model are essentially like a beginning like AR1 model of the last. So this is one of the main similarities between alpha for count as a for the product, for the valuable quality. So then how do you explain the parameter? That's what I mean in that. So we can use the generalized quasi empirical. So here we are assuming the two things are resistance from the two moments actually about so this is a general equation for the if we have a equation y minus 2 is the equation for the mu, so we can find out the sigma inverse and d mu by d beta. So this is a generalized quasi negative equation. Or we can say that in this particular case, we can say S transpose mu in minus y minus mu. Because mu is a function of. So we can get that, and this equation can be. So this is the one, and the u is the direct. Right, and I do before. So this is actually the equation based on the possibility, and we can solve those equations by any numerical method, and we use the numerical method and we proceed here for a given value of rho 1 and rho 2. So we can estimate it by the system like this in this story that has plus this is inverse. We take one more derivative and get it that this is and evaluate the current value of the we can actually get it given value of rho 1 and rho 2, we can estimate that. So then we need to estimate the parameter rho 1 and rho 2. Those you can see that if we define this SPT equal to this one, vertical so it's a standardized version for that. And when you standardize the SPT to this one of this one, so we can see that we can generate the equation for the rho 1 and rho 2. So this is, for example, SPT is going to be 1. So we can see this is equal to SPT plus 1. When this is going to be the equation for that. Yes, so this is the SPT plus 1. So this is the multiplication is going to be. And for the second case, we can solve this equation for that. So we can get easily what the rho 1. Then we can either plug in or we can divide it and we can get the value of the. So we can get the GMO equations and directly first one that rho 1 equal to this and rho 2. You can solve that equation here, the second equation, this equation. So rho 2 this equation. Then you can iteratively also can do that. So G is the function of rho 2. Let's see by this equation. Then we can solve, we can find out the rho 2 iteratively. So this is equal to 0 when you solve. For given value of the mu rho 1, you can solve iteratively. But here you can get the rho 1 exactly possible. So the equation procedure is you can get the rho 1, get the rho 2 iteratively, then plug in the value in the here, you can get the solution of the equation. So that is what procedure is. So that is the binary process that we have. So now we can have a binomial process. So each individual can produce maybe NI observation or NI observation can produce, NP observation can be produced. So then the process will get entire things are changing. So external moving average model could be so then basically everything is changing. So we have to do the derivatives again for the and so it is just same idea. It's from the binary theory. So the basic property is going to be different. P equal to V1 for P equal to 1, P equal to 2, equal to this 4, P equal to 3 or P equal to 6. So the function also will be. So this is when you go to a binomial Austrian case, and distribution parameter is very same. It's no problem. It's not the same. We can use the GPM estimation and we can also move the GPM estimation. So when the formulas are going to be changed, these formulas are going to be different. So, so you can also go a special case of the same situation where each individual can get any fixed number. So anything in varies for each individual can speak, but you can have a fixed number that you can do simply for so already the regulation is going to be taking 5 days or fixed value or anything to okay, then I think very distribution is very fast. So developing the distribution of deep estimate, so we can have the vertical outline the figure and figure. So these are the two papers we're talking about the analytical distribution of the usage when we do the setup. They ask you the dual setup is not for any points of the case. But then when we have the condition, we can show that the GPM is maybe taken better given by this. And this is the last key that we the time price that we take for the infinity. There is maybe difference in particularly. We can not both in the own data and the following system. So we can easily for that. And this is a simple part we see just to show how the path is going there. So we have a simple thing like binary offspring from data, might be this one and the week. So this is something and considering the XP to 3, we go to carefully to carefully and 1.5 data into the weeks and go on go to 15 values of these including the ready. Then I'm a model for the continuous data also you can see this quarter. And using this 500 and this one you can get that data use. So we can see the pattern is more or less same. Not that much different. Well, because the upper one is going to be used. So we can see that it's not that much difference in this. And we send the same situation, the simulation. So how the simulation is going to work? So we have the kind of P and this binary we could get SOVA binary point for and the SP2 equal to P to T. So we can just say 1 by T, 1 by 100, 2 by 100 like that. And the average is based on the processing. So, for example, the time T, we put the 250 points, 500 points, and 700 points. We assume the beta equal to 0 and 0 and beta 1 equal to 0, beta 2 equal to 0. Here, the same situation we put 0.3 and 0. And row 1, row 2, different values. And we see that how the students are coming here. So we can see that function simulation that average is coming in this line to 60 and this one. So there will be 0, 0, this slightly higher here, but when the sample size is coming in this one, going to be so that is the bias is going to be here. And this is standard error of this standard. The first one is 0.0020 here and 2.001. So this standard is also very small. Bias is also very. This estimate of the row is 1 is 0.3 and you can see that for 250 samples coming out in 0.47, but we see to and as you can see, the Australia found data which we need to have this actually. And the standard road means that over that, and we see root 2, 106, 101, so these are one cases, similar cases that we can see that the values of the background and you can see that the bias is so this is our setup also. So different values of the data So we try to give a different, generate the data with the different parameters and see whether the distribute sometimes correctly and the standard. So this is the so so we will go in cases I think it's very static to do now. We don't go to the models and they just it's little much where now we just learn we have to do so the proposed AR1 model for comment are similar features of the AR11 model and ICSTC, and we have similar features in the GAM4 and the problem again is we identify the appropriate model for available for the counter structure. So when we have a data set, we need to have defined what type of model we can use. For example, if we say one model and and go to is being zero, then we can say closer to zero, then you get approximately R1 model. That's possible. But we need to have an idea how we really do that. So this model can be also like a complex unobservable effects in the fencing, the random effects of incorporate. And also we can look at the alma model or high order like we like that, even master species or not there. Not a few are so this time. That actually is beyond there, so it can be done. Okay. These are some of the lot like nice and great. Any questions or comments or welcome? We have appreciate that. That was in my PowerPoint, but it's the same color for the but it is not a direct feedback. Let the scientific invite our next speaker, Professor Yagin Thomas, for this presentation. Professor Yagin Thomas was Emeritus Professor in the Department of Strategy. And my student is of course, and he was the director. We have right, Dr. Daniel Thomas.
അങ്ങോട്ട് അയക്കാം ഒരു സെക്കൻഡ്
Yes, please.
മെയിൽ ഐഡിയുടെ പേര് സിയ
കട്ടായത് ഇവിടുന്ന് സ്ട്രീമിങ് ചെയ്യുക. മീറ്റ് കട്ടായി. ആ സെക്കൻഡ്. Oh, just it. This is the point system. It makes me involved in this system. This today we are going to hear a talk on in a newly very business using statistics for the family of certain distributions. This is designed for me and this is the this work, we consider a new class of statistics obtained by ordering the absolute values of the observations drawn from absolutely continuous distributions which are symmetrically distributed about zero, and this forms the problem of interest here. Now, these statistics are termed as absolute order statistics. They are order statistics, but not the usual order statistics. For example, if the observations are 0.8, 2.1, etc., then the absolute order statistics are being just taking absolute values of those values and then order. Such statistics are also order the random variables, but not seen usually much in theoretical deliberations. The association of absolute order statistics and order statistics arising from the folded form of the theoretical density also will be described. A method of estimation of the scale parameter of any distribution belonging to the family of all absolutely continuous distributions which are symmetrically distributed about zero are discussed. The advantage of this method for logistic, normal, and double variable distributions are also are to be illustrated. A more realistic and sensible sensorial scheme involving absurd order statistics as well is discussed. Narration of the derivation of the use statistic estimate based on absurd order statistics for the scale parameter of any distribution belonging to the family of symmetric distributions and its performance with the other traditional estimates as well will be discussed. Lefman and Chappé proved that T equal to X of the order statistics of order statistics forms a minimal sufficient statistic, which is also complete for the family if theta of all absolutely continuous univariate distributions. One claim of the advantage of using sufficient statistic T in inference problem is that in such a case no information will be overlooked. But the above statement needs more clarification. A sufficient statistic T is said to be minimal sufficient if any further effort to made to define a statistic T dash with the reduced partition on the sample space, then T dash loses the property of a sufficient statistic. Note that in terms of information contained in a minimal sufficient statistic T and a simple sufficient statistic T dash, both of them contain the entire information in the sample. Then what is the advantage of T over T dash? To explain the advantages of universal Bayesian statistic, consider the uniform distribution over the interval minus sigma to sigma. Since both terminals of the range of the distribution depend on sigma, it is well known that epsilon is the smallest and largest order statistics together forms a sufficient statistic for sigma. It is clear to note that if x follows uniform over minus sigma to sigma and y equal to x by 2 sigma plus r, then y follows a uniform distribution over 0, 1. Therefore, the statistic given in the left side is distributed identically with the y1 and yn, where y1 and yn are the smallest and largest order statistics drawn from uniform distribution over 0, 1. One can now easily prove that true sigma star of sigma based on epsilon and xn is sigma star equal to n plus 1 by 2 n minus 1 into xn minus xn with variance sigma star equal to 2 sigma square by n minus 1 into n plus 2. But from David and Nagaraja, we observe that T equal to maximum of minus xn minus xn as minimal sufficient statistic. And the best estimate of sigma based on T is sigma cap equal to n plus 1 by nt with the variance sigma cap equal to sigma square by n into n plus 2. From variance sigma cap and variance sigma star, it is proved that variance sigma cap less than variance sigma star. Thus, we conclude that though the sufficient statistic xn contains the entire information of sigma through its definition. However, optional methods we apply on it to estimate sigma strip away some amount of information. When compared with the use of MSS, minimal sufficient statistics, clearly the class of all symmetric distributions which are symmetrically distributed about theta equal to 0 called n theta 1 is a subclass of the class of all distributions which are continuous, absolutely continuous. Hence, there is a wrong perception that T equal to the vector of order statistics is also minimum sufficient for the class of all symmetric distributions. Clearly, the class of all symmetric distribution is a subclass of distributions of the continuous family, and further, if the class of all continuous distributions contains many well-known distributions like normal, logistic, Laplace, double equal, labels, Kudelski, and the Cauchy, as always. The third Huygens hypothesis on the theory of arrays specifies that each component of error has an equal chance of being positive or negative. One important class of distributions satisfying this Huygens hypothesis is defined by the PDF given in the last equation. For more details of further families, see Thomas and Priya 2015 and 2016. And one important point which contributes for this in our work is the paper by Rosira and Etal, as well as Ram and the race 1991, both appeared in Communications and Statistics. They have discussed above and an estimator called optimum and revised absolute estimator, which is calculated as OUA, which was a linear function of the absolute values of the order statistics that drawn from some distributions of theta 1 and illustrated that their estimator is better than the receiving is common order statistics for the scale parameter sigma. The above observation gave a proof to the idea that the statistic order statistics cannot be made inverse sufficient statistic for the family of continuous distributions which are symmetric about 0. And instead a modified form should be the minimal sufficient statistic for the theta model. So our conclusion is for such a family, order statistics cannot be movement sufficient for the further modification there. To identify the universal sufficient statistic, we define the following definition. Suppose x1, x2, etc. xn is the random sample of size here drawn from a distribution with the period of theta x such that it belongs to theta 1. If we take absolute values of the observations and order them in the equation of magnitude and the notation is x1 within bracket. First observer statistic less than second observer statistic, etc. This is said that the newly ordered values given as x1, x2, xn are within the bracket or the observed statistics of the given standard. The likelihood for this case is f theta is equal to y product of f theta x or I equal to a. Since f theta x is totally zero for any given set of reals, x1, x2, etc. xn, the likelihood is the constant for all n factorial permutations iodide etc. n of 1 to etc. integers 1 to etc. n as well as 2 power base of assigning f1 is minus 1 power j for j equal to 1 to with each of the components xi in the vector x1 etc. Thus, if T is the statistic defined by observed order statistic, then the conditional PDF of a given vector x equal to x1, x2, etc. xn of reals given T equal to T specified by the observed order statistics x1, x2, and xn is given by n x given T equal to T equal to 1 by 2 n factorial, which is a constant for all f theta belonging to f theta 1. Clear of the above property is requested as given in letter limit n is 62. We obtain the following theorem. Suppose x is the vector of random sample of size n drawn from a distribution between f theta x belonging to f theta 1. Let T be the statistic based on the observed order statistic constructed from the original sample of observations. Then T is the minimum statistic for the family in theta 1. Given the sum observations from f theta x are absolute values of those observations is distributed identically as the vector of observations drawn from the PDF g theta x equal to f theta x for x greater than or equal to 0, which is the older form of the density of f theta x above x equal to 0. Hence, the observed order statistics x1, x2, and xn defined from the absolute values makes us to say that the observed order statistic is distributed as the vector of order statistic of random sample of size n drawn from the polar distribution with the density d theta x equal to 2 n theta x for x greater than or equal to 0. Suppose that we have an observed order statistics of random sample of size n drawn from a state parameter, the family of distributions with density f of x sigma equal to 1 by sigma f0 x by sigma, which is the general form, where f1 is totally distributed about 0. If y again equal to x n by sigma for I equal to 1 here, then the vector of observed order statistics of these standardized variables is the vector of variables which is distributed identically as a vector of absolute order statistics of random sample of size n drawn from the same density f. Now we write the following theorem, which use the idea of distributing sigma using observed order statistics. Let us see the vector of observed order statistics arising from The density f of x sigma is a scale family with the density 1 by sigma f naught x by sigma minus infinity less than x less than infinity, where f naught x is equal to 0. Let y is a vector of order statistics of a random sum of size n arising from the density with the gy, which is a standard form of the original order density. Then, for expected value of the vector y equal to vector mu, and the dispersion matrix of y is given by dispersion matrix of y equal to g. The blue theta of sigma based on the vector of order statistics is given by equation 2.1. The variance of the estimator is given by 2.2. These are all results forming out of the last Markov theorem. It is straightforward to note that the proved derived theory also may be written as sigma cap equal to sigma equal to 1 here, linear combination of observed order statistics. Where C here and equal to 1 here are appropriate constants. Now, we see what is the relation between the blue based on observed order statistics and the blue based on order statistics of the whole linear distribution. Is the only effective and essential are the order statistics of a sample of size are arising from the standard form of the basic density Gx equal to 2 f naught x by sigma. Then also expected value of the vector z is mu sigma, where mu is the same between based on observed order statistics. Therefore, expected value of Z is equal to vector mu sigma. This first matrix of Z is sigma square G, where G defined here is also same as the same mode of G defined for determining the estimate sigma based on observed order statistics. So that we can write sigma cap equal to n equal to 1 p of C such in IN, in which the C are same as the C defined in theorem 2. So we have in theorem 2 and theorem 3, we have serials, they are one and the same. Thus we conclude that in the proof of sigma based on order statistics from the whole density, sigma is equal to f naught x by sigma, we can obtain the proof of sigma involving f of sigma equal to 1 by sigma f naught x by sigma, just for in sigma cap based on the older density by is explain the third order statistic of the order density. So we conclude no based on the order statistics from the order distribution, you then in that flow we place the underlying equation by the order observation, corresponding observation of the normal distribution. So this is a very simplified theory proves it is highly helpful to determine the explicit response for the estimate of the symmetric distributions during the family in theta 1 based on the results that are available in the order distribution property of estimates. So in the former case, observed order statistics, the latter case, they are order statistics for order distributions. To illustrate the advantage of this meta proposed in theorem 2, we now consider the value of logistic distribution with the PDF given by 2.4. By the proposed method, we need to calculate the mean variances and covariances arising from the standard half logistic distribution with the PDF 2.5, which is the standard form of the logistic distribution. The coefficients AN in the blue based on AOI given by sigma cap equal unequal to C and HCl have been computed and are presented in the table. And you experience sigma cap the variance of the optimum unbiased absolute estimator is also given. Variance is equals to, which is the variance of sigma theta. The standard variance of ML is sigma theta, say variance of sigma theta equal to 1 by n delta sigma square or delta equal to 3 by 3 plus y square by n. These are actually results collected from the existing literature. Or the rules because based on our statistics have been all computed and the relative efficiencies of sigma by power estimator with respect to the classical group based on our statistics and mostly our estimator sigma square with respect to sigma star as well as efficiency of our estimate is equal to that of MLE. They are computed for any equal to 1, 2 at the interval 1, 2 up to 10, at the interval 2 up to 20, and are given in the following table. So, you see, the first one is the variance of classical estimator based on our statistics. The second one, the variance of our estimator. The third one, estimator of Mosaic, OAE, and the other one, the last one, variance of the maximum likelihood estimate. You notice that maximum likelihood estimator, the variance is valid only for normal sample space. For small sample situation, analysis is excited. So, logistic distribution, the maximum likelihood estimator is non-existent, which is not exactly non-existent. It doesn't have an explicit response. Explicitly available. So the efficiency of our estimate, the efficiency based on the efficiency of Rosera's estimator plus the partial estimator is given by the third from the last column. And estimate of our estimator related to the classical unbiased estimate based on our statistics given in the next column. And the last column is crucial. The efficiency of our estimator related to maximum likelihood estimator. You see, it is very close to unity estimate going on from 2 to 20. In the small sample case again, we use for 2, the efficiency is 7.98%. So, if we notice that, the estimator is only a good estimate. And the value is only for the data set. But the data estimator is basically used for any service. So, that is the case with this disposition, logistic distribution. The table illustrates the better performance of our estimator over its competitors, Ocean's estimator, and the classical estimator based on this order series. Further, the efficiency is very close to unity when it is compared relative to MLE. A more elaborate discussion and table and other tables involved can be seen on Thomas and Angela 2022. Now, we discussed the same arguments as to normal distribution, and we actually apply the theory developed in this paper. We find the estimator, their variances, and efficiency comparisons, and those things are given in this table. It is for normal distribution. You got the last column, which is the efficiency of our estimator with respect to the maximum likelihood estimator. We see that almost 80 or 89% of the efficiency is actually taken by our estimator and covered as the maximum likelihood estimator. Therefore, illustrates better performance of our estimator over its properties, case procedure system is a sequence of and the classical unperceived based on statistics. Further, the efficiency of the leading to the element is the course field. As a side illustrates, we offers the graphical level distribution with the density function given as alpha by 2 square for alpha, 1x for alpha minus 1, e power minus 1x plus 6 for the 1 for alpha. When alpha is known, 0.500 alpha equal to 2, we have calculated the mean variances and covariances of order statistics arising from the standard half variable distribution with the PDF given in the next equation, the alpha y. The coefficient Kn is the proof based on the OS given by sigma capital equal to sigma I equal to 1 Kn have been computed and that was the table. We have computed as in the previous cases all of those values of sigma cap, sigma star, and sigma double cap, values of MLE, sigma delta, and those things. Together with the efficiencies compared with the previous information, which is are all given and are given in tables 3 and 4. This is for alpha equal to 0.5. We discussed about the estimate for n equal to 420 and last part. More than 90% of the efficiency is observed on the side. When compared to maximum likelihood estimator, maximum likelihood estimator is applicable only for small large samples, but here it is applicable for any samples. So we know that these efficiencies are covered up to more than 89% for any given. This is for alpha equal to here. At most, the internal efficiency is covered when compared to maximum likelihood estimator, and that illustrates the supremacy of our estimator and our boosters of our estimate with the maximum likelihood estimator. Here, 3 and 4 illustrates the performance of our estimator over its quantity case, Osiris estimator, and the classical estimator based on order space. For the efficiency of the our estimator related to the MLE for both alpha equal to 0.5 and 2 are very close to infinity, close to unity. For complication details, both C, close and n-22, and those and others will be. Now, we discuss about the place. When sampling provides total distribution, if there is a clear occurrence of a series observation outlier, either the largest or the smallest observation is considered as an outlier. Hence, if one is interested to have a robust estimator of the scale parameter sigma, which is not a statistic mostly capital-sensory is considered. If outlier is considered as an observation, which is the most farthestly lying observation from zero, then the largest absolute solved order statistic is chosen as the unique outlier of the sample. So that a right sensor sample, the right sensor single absorbed order statistic provides absorbed order statistic sample for estimation of sigma. Instead of simple outlier, we can have three outliers as well. So we have the following theorem, which describes the estimation of the parameter in terms of outliers. In this case, we assume first k farthest observations as k outliers of the system, and in use case, this theorem describes about the estimates that we obtain in sources in sensor samples. We said this type of system is more excellent because in the case of system based on order statistic, we are sure whether the most is the smallest or most largest That's to be discovered. But here, immediately it helps us to discover the parts of the by considering something only. So it is more realistic and practical. The blue obtained in the Yemokia, Pagriculus, Equantian Catholic, equal quantity in Ministry, see and which is a known constant with the DXA as well, but some other studies. And these CA of eight constants that can be computed from the matrix equation. Constant antenna determine the coefficient CA for unequal quantity in Ministry for logistic normal and level variable distributions are equal to 10 and are calculated in a table. The coefficients for Cauchy distribution as well is available in other paper, Thomas Saturdays 2022. So usually the Cauchy distribution is a problem method. In the case of using all the statistics from Cauchy distribution, we have basically the equivalence of two objects. Whereas if we put on observer statistic, we need to send only two observations. One is observer statistics these vacancies. So that is another advantage of dealing with the graphical estimation in the place of Cauchy distribution using observer statistics. And the variance of the estimates contain can evaluated for any coefficient being computed and it is estimate is equal to complete sample row based on AOS are available for the above distribution logistic normal and double vehicle are available and the details are given in this table. As an observation from the table 5, we observe that when the number of AOS observed by the studies, so it's not too large. There is not some efficiency for noticed in the estimates, 6.8 gap. If the equals the other sensory estimates, the efficiency of change is larger than 61%. Thus, when compared with the sensory, these are not a statistic. The estimate is very out. Based on sensory is AOS are calculated in more rows. More details, see the web page. Now, use statistics is a broad theory in the area of statistics, and it is use statistic theory is considered as only now breakthroughs made in statistics. And working in the 48, we released first the cost of estimates for new statistics from advanced estimates of parameters among taxonomists. Where these estimates are advanced and distributed asymptotically normal. This theory is considered as the top 20 breakthrough made in statistics during 20th century. The new statistic generated from blue based on our statistics kernel was developed in our department, University of Kerala. New statistics distribution carried out for linear responsive distribution, skew normal distribution, log gamma distribution, typhoon generalized logistic distribution, normal logistic typhoon testing value distribution, log logistic distribution, typhoon generalized logistic distribution, etc. And even beta function distribution. All these theories have been developed from our department and obviously various languages. The theory of developing new statistics based on proof of observed statistics as is also exactly similar to that of evaluating new statistics by proof based on order statistics as kernels. Hence, we describe the theory. The observed order statistic form a minimal solution statistic for the family FT1 of continuous distributions. The new statistic generated by proof based on observed order statistics supposed to be more efficient than the new statistics generated by the corresponding order statistics, classical order statistics for the state parameter sigma. Suppose if so that we get an observed order statistics drawn from fx sigma equal to sigma not x which is sigma. Let Z1 is equal to BA. We The order statistics are a similar example. Z1 Z2 Z1 of size run from CS sigma report at call. Then expected value Z1 by Z1 by sigma Z1 by sigma equal to delta V, where equal to U1 M etc. And the distance from vector is T. Then the blue based on the EC set the water statistics is U dash T inverse of mu power minus 1, U dash T power minus 1 sigma. The distance. And its variance is given by variance sigma cap equal to U dash T inverse of mu power minus 1 sigma square. This sigma cap can be also written as sigma K M is the M. Suppose Z1 M Z1 Zn are all statistics of the same distribution. Then from Thomas and Slayman, we write the U statistic derived from the Thermal. And Z2 equal to C1 M Z1 M plus etc. CM Z1 as the U statistic defined by that thermal is written in 4.1. And notice that in the subsequent steps, we use the definition XCY is taken as zero on we X. Because we have got that notice to avoid controversy. If you write the size M as variance between two IC statistics, you will exactly see variables are common for equal to TL. Then variance of UN and the U statistic can be written as 4.3. Clearly, size M, the size UM, and the variance of the U statistic is 1 by LCM, sigma equal to NCC, N minus MC, MNC, size M. These are all per piece theory, just translated to this one. Clearly, size M, when exactly all the observations are identically same, the coherence between two isostorages M common is exactly equal to the variance of the thermal function itself. If you put M equal to M plus K over K is a integer from 1 to M minus 1 in 4.1, then we get equation 4.4. We can write the above equation as U plus K M equal to Bm plus K dash Zm plus K, where Zm plus K is the vector of order statistics of M plus K sum. And Bm plus K, the vector consisting of the coefficients of Zi M plus K for I equal to M plus K. If G plus K is the variance coherence matrix of the above vector, then variance of M plus K M can be written as with the usual mathematical theory, it is Pm plus K dash Cm plus K Bm plus K multiplied by sigma square. We will write this as W equal to equation, the equation. So the above discussion we define for not looking the SK into L, C equal to 0 E is that 2. Now from the U statistic we have the following simultaneous following equations. So for we are used to M minus 1 values, so it will be so almost psi 1 M, psi 2 M, psi minus 1 M are components of the variance of the statistic. So M minus 1 components of the statistic variance. And we already defined what is W1, W2, W minus 1, all of these. The values psi 1 M, psi 2 M, psi minus 1 M, the different psi M components are required in variance of even M can be now solve from the above equations, and then we can write the U statistic derived from the group equation. M is the kernel as 4.7 and its variance is given in 4.8. From the theory of U statistics, we can obtain the systematic variance of QNM as must start accumulating young people to expand again, Simonian, or the statistic DNA equal to UNA minus sigma by root of expand and Simonian of text to distribution in this mode. This is an advantage over the classical order statistic theory. Classical order statistic understanding distinct reciprocity is not at all related. But here, if you make use of use statistic theory, it is explicitly available. So even one can be used just for testing problem or testing whether sigma is equal to some specific value. So that is the advantage of this use statistic theory. Now we just illustrate the theory of the spiral property for obtaining the estimate of sigma using a formal setting from the logistic systems. If you make use of an initial sample of 5, and then the kernel can be derived by making use of the theory developed and is given the weight center of the last equation. Using this kernel of the 5, we can obtain the new statistic U and 5 estimate of sigma for the half logistic distribution. In U and 5, if you replace each instance again by the corresponding observed order statistic, you can say equal to that original distribution for I equal to 1 PM. Then we obtain the recording statistic estimates U and 5 based on AOS arising from any specific distribution. Further, the components size C5 for determining the variance are obtained as sigma minus 2 psi 1 as 0.02 and other things as a switch filter in terms of different values. The above values are used to compute variance for n equal to 10, 0.20, greater than 20 at equal 100 and are given tables. We have computed variance of NO means order classically order statistics involved in the statistics, as well as rule based on actually our estimates and those rules are available in tables. So UNA means the new statistics developed based on observers. UNO means new statistics based on classical order sets. Clearly, our estimate has lesser readings than the readings based on the classical order sets, and the efficiency is correspondingly larger than one. From table 6, we can note that in estimating the scaling parameter of logistic efficiency or efficiencies and then astronomic efficiencies of new statistics classically, not classical or observer statistics. Derived from rule based on observer order statistics, someone related to statistics, classical order statistics, as kernels of the defined or greater than unity. This supports the theoretical assumptions of the graph regarding the universe and the universal intensity for the family level, so that the concentrating on it is the better results of the difference procedures of the family. For whom the not exists for the operators. So the sum of occurrences is proud and others that is the basic paper, which makes us to go in this direction as true.
You also need time to because
Now I invite Dr. P.G. Romeo to hand over a economic now to our honorable speakers, Professor Ashwin Malik and Professor Yagin Thomas.
Dr. C. Sadish Kumar, present a memorandum to Dr. P.G. Romeo, Chief of Appreciation. On behalf of the organizing committee of ICSTC 2024, I extend my sincere gratitude to Dr. P.G. Romeo for your invaluable contributions to chair the session. Your expert in applied mathematics and mathematical modeling, combined with your academic excellence, has left an indelible mark on all of us. We are very grateful for your valuable time and effort for sharing your knowledge and inspire. We would also like to thank Professor Ashwin Warrior and Professor E. Yagin for the engaging presentations. I also thank every participant for your valuable contribution. So once again, thank you, sir. Now we have a tea break for 15 minutes. Next session will start after that. So everyone should press here by 3:40 itself. Thank you.
ആ ചേച്ചി വയറുണ്ട് അത് കുത്തി കുത്തിയ വരും ചാർജ് എത്രയാകുമ്പോഴത്തേക്ക് ഓൺലൈനിൽ ജോയിൻ ചെയ്യാൻ ബാക്കിയുള്ളതെല്ലാം റെഡിയാക്കി ഒരു 9:30 ഉണ്ട് ഒരു 9:50 വരാൻ മതി ഒരാളാകുമ്പോ നാളെ ഉച്ചക്കലത്തെ ടീ ബ്രേക്കോട് കൂടിയേ ഉച്ചക്കലത്തെ ടീ ബ്രേക്ക് കഴിയുമ്പോൾ ഓൺലൈനിലാണ് ഇവിടെ ആ ഓൺലൈൻ കുറച്ച് ഓൺലൈൻ അതിലൊക്കെ മനസ്സിലായി ഇവിടുന്ന് ആ സമയമൊക്കെ ആകുമ്പോഴത്തേക്ക് കുറെ ആൾക്കാർ പുറത്തേക്കുണ്ട് രാവിലെ ഇവിടെ ഇന്നില്ലല്ലോ ഇല്ല ഞായറാഴ്ച ഇപ്പൊ ഓൺലൈൻ ഞായറാഴ്ച നമ്മൾ തുടങ്ങി കഴിഞ്ഞാൽ രാത്രി 10:30 വരെ നമ്മളെ ഞായറാഴ്ച നല്ലപോലെ കംപ്ലീറ്റ് ചെയ്യണം ഹലോ ശേഷം മനസ്സിലാക്കണ്ടേ ആ ആ
Hello everyone. We are moving on to the technical session 4 of ICSTC 2024, an invited session chaired by Dr. Ashokan Varadkar. Dr. Ashokan Varadkar serves as the Associate Professor of Statistics and as the Director of Statistical Consultancy Center, Department of Mathematics and Statistics, Memorial University of Newfoundland. His areas of interest are machine learning, statistical process control, empirical likelihood, variable selection, etc. He has many research publications and has been awarded Dean's Award for Service Excellence, School of Graduate Studies, MUA. It is with immense joy that I welcome you, sir, to chair this session. Without further ado, over to you, sir.
Good afternoon. So we have the technical session number 4. So we're going to take 45, 345 to 445. Okay. So we have two speakers for the session. The 25 minutes for the session. And the first speaker for science education section. The types of the topic for the conferences for the young people on the university for the moment.
Thank you so much for the introduction. Yeah, so good afternoon everyone. Today I will so today I will discuss about or I will talk on this thing. So this is basically a research with one of my PhD students, Kaushik. So yeah, this is my presentation over there. So in the beginning I will say little preliminaries and then what is this testing program? This thing I will and then I will go into my original program. Okay, so let's see what first what is reliability? Reliability theory broadly definition and you like on some components or some components. It may be a biological component or it may be a mechanical component or it may be a particular like computer software package or something. Okay, we are basically starting the lifetime of that particular item or maybe the maybe some component of that thing. Okay, so basically what we do, we model the lifetime into non-negative diagonal. Here I am denoting that non-negative diagonal by X, and we are considering it has this CDS effect and survival function, which interpretation is it gives the probability that it is surviving beyond scientific model. Okay. So this is called the survival function, and several measures are there, several functions are there that are important in understanding of relationship theory. One of them is this Hazard function. So Hazard function generally denoted as this RFT and is defined as the ratio of density function by survival function. It has a nice physical interpretation. It's basically saying if an item is surviving beyond time phase, then what is the probability that it will fail in the instantaneous within a small time frame? So basically, it will fail between x-ray per meter. This is defined as periodic Hazard function. That's another thing called also periodic function. Okay. Next thing, another function is there. Another function of fundamental importance is this mean residual life function. This is basically the expected remaining lifetime of an item. So if an item is surviving beyond time X, then what is expected remaining life? This thing is basically defined as the mean residual life. Okay. And based on this, like survival function, mean residual life function, and Hazard function, several non-parametric rating classes have been introduced in sequence. Okay. I will briefly say about that. And not recently, there is another function. It's called the mean time failure function. It was initially introduced by Barlow in 1961. But not many. Okay, that time it was not basically get much attention, but in recent times it's got many one or two editors have been defined on this thing, and I think now they because got focus on this thing. Okay, and this mean time failure function is basically it's the expected time to first in-service failure. For example, some component is there, that is going to an age replacement quantity with age. Okay. Now the thing is, we are interested that if this thing is repeating, if we are following a replacement policy with age, then what will be my first in-service failure? In-service failure means, so between this time period 0 and X, I will replace it at 2X, I will replace that. Again, I am expected to replace it in 3X. Now the thing is, what is the expected time that it will fill between this some X and N plus 1? That expected time is given by this, that expected first in-service failure is given by this mean time failure. So each of the components we can utilize this to again, for example, it can be used in level economy also. We can consider that all the rivers who are watching a particular farm or something, they have a failure time like retirement time. So okay, so we are replacing that retirement. But now the thing is, one person can leave that farm. Okay, so we can basically leave that farm and go somewhere else, or maybe he might quit his job, or maybe he might die. So we will consider that thing as an in-service failure. Otherwise, we are replacing the thing as its return. So this X is fixed here. Now based on this, so we want to actually understand what will be my expected first in-service failure. Okay, that thing is given by this mean time failure. And yeah, so based on these three functions to model these notions of aging. For example, there are three types of aging. First of all, what is aging? Aging is basically in the context of reliability theory, we understood that the effect of age, what is the effect of age on the residual lifetime on the molecule in some problems. Okay, so this is called aging. Now it can be, it is basically it can be categorized, it is classified in three categories. One is no age. What do we mean by no age? If the age does not have any effect on the residual life. Okay. Similarly, the positive age is if the age has an adverse effect on the residual life. Okay, and where negative age is opposite, that opposite, and it represents that it has a beneficial effect. So, for example, Politically, we can think of given life. So we take our residual lifestyle is decreased. Okay, already you can think of AV, or you can consider this AC. So we start with lifestyle is decreased. That is an example of positivity. And negativity example it might be, for example, when we are largely typing for the first time to computer. So we are more prone to make mistakes, right? But with over time, when we are using or we are typing for longer time, then our mistake can be reduced. So the thing is, in that case, we can say that A has an very easy effect in the residual life. Okay. That is called the negativity. So to model this aging, so based on this three functions or based on this reliability function, say for non-parametric aging class can be included in the aging. For example, this alpha in its full form is increasing failure rate or increasing failure rate class, and its dual is called the decreasing failure rate. Decreasing failure rate class. So it is basically defined based on the failure rate class, based on the increasing or decreasing property of the failure rate class. Okay. Similarly, this alpha it is also defined as based on this property of this failure rate function. And there are many others like NDU based on this survival function, NVU based on this median life function, and there is DMRO, HMV also. I'm not going to, but I will focus to based on this DST period. So based on the mean direct failure function, to a class it's the thing is decreasing mean direct failure. So if the mean direct failure function is decreasing, then I will say a number of and orange is dual and dual class is called the decreasing mean direct failure or the INT failure. Okay. So this will be our main focus here in this talk. Okay. So and if we just consider these are all non-parametric aging. So here we are not considering any parametric form. We are only considering this all this basically all this distribution coming from this property that is in interior function is interior function is a decreasing function. So if we see the hierarchical relationship among the entity class, so then DMPT is right here. So it is larger than alpha LDU, okay, and it is smaller than the LDU, and it is smaller than the LDU. Okay. Again, there is an intersection between DMR and DMPT, but they are not kind of contact each other. Okay. So there is an intersection. Okay. Now I will basically my main problem is to test how exponentiality against variability works. Right. So now what is the main motivation for testing exponentiality against non-parametric aging? So I describe about these three types of aging: positive aging, negative aging, and no aging. Now, no aging means age does not have any aging. So that means we can consider that we can avoid the property. That means it is always as good as aging. Okay, and we can think, for example, if the lifestyle follows exponential distribution, then we can consider this no aging property because we have never property exponential. Right? So now, what is the motivation of basically doing this kind of test, testing exponentiality against the particular aging class? The first motivation is if some data is given to you, then obviously it will be beneficial for us if we understood that from which aging family or from which aging class it's coming from, right? So that will be a main idea. Now, if we can predict that it is coming from a particular aging class, advantage will be we can use in the theoretical side we can use the survival probability bound, maybe the bound for the given function, or maybe the different probability that are available for this survival that we can easily use. Okay, and in the practical point of view, what we can do, we can use more precise estimation data. Okay, maybe we can for more economical replacement policy, or maybe we can think of better optimal therapy plan. Okay. So now this exponentiality, why this exponentiality is important? So that I already mentioned that it is so this exponential is memory property. So people can say that if I can one item is followed exponentially, one item with exponential distributed lifetime is stochastically similar to say that it is as good as me. It is always as good as me. Okay. And another thing is there. Another advantage is there. So if we test for exponentiality for the period of time, then it is equivalent to say that the sums that are responsible for the value are coming from counting process, which is coming from the homogeneous quantity. Okay. So several work based on different aging classes has been done in literature. For example, these are few kind of literature I am giving here. So for example, this ISO library it's done. It's long back. It started in 1970s. It started from there, and still this kind of work is going on. And it's yeah. For example, for DLT alternative, recently many work has been done. For example, in 2016, Akumul and Anisa did one work on based on this new statistics approach. Then later to realize it for statistics approach using statistics approach, and this both modules are propose a method based on this statistics and basically exploit the human inequality of DLTPF alternative. Okay, now this is my main problem. So my main testing problem is we want to test our null hypothesis with A, that is my lifetime or yeah, this lifetime, this particular component or something that is coming from exponential family, or it is coming from this DLT based on the random sample Xi. Okay. So here this guy basically denote the exponential distribution with typically unknown. This parameter is unknown to us. That is we want to test. Okay. So first, how we prepare our since it's an alternating error, we have to prepare our test statistic, right? So we basically prepare our test statistic based on this moment inequality. So we exploit this moment inequality for the negative variable to prepare our test statistic. So we derive this moment inequality. That's yeah. So this is for the arithmetic moment for this is to all integers, get all positive integers, and where this new one is basically the extreme of x1, x2 to the power, where x1, x2 is integer and I cannot be degree, having the distribution function a. Then this moment inequality will hold. So now, based on this moment inequality, we prepare our case studies. And it is one thing here, it should be observed that if is belongs to the exponential, if becomes exponential, then this inequality will be an equality. Equality will hold them. Okay. So now based on this, and if any DLTD is coming from this DLTD variable, then this inequality will stick. Inequality. Now we are utilizing this inequality to prepare our case statistic. So see, observe that we are taking this term in this left hand side, and we are making our measure of deviation. Okay. Now, first of all, this become our measure of deviation. So what is happening? If this A is belongs to DLTD family, this TR will be a positive number. Okay. And if it is coming from exponential, then it will be equal to 0. The result of the TR equals to 0 for under H0, under an analysis, and is strictly positive under H0. Now to make this test statistic or make this measure and scale variant, we are considering this measure of deviation as this weighted measure of it, or basically this we are considering. Here star equals here to the power alpha. Our main intention is to make our test statistic the one of the basically to make our original test statistic scale variant statistic. So we estimated this PR star here. So by this, so we utilize this new statistics for estimation, and we are having this kernel here, this one, and we are now for assigning that of our test statistics, we are utilizing this standard statistics here. Okay. So yeah, few things here to mention. See here. So for this is our test statistics. Now it depends on R. Okay, now main advantage basically it's giving a class of test statistics. The advantage is we can choose particular R for particular particular data or R. So we will see in similar studies R into influencing the power of the test. Okay. So that's why it's basically class of it's giving a class of test statistics. Okay. Yeah. Now I'm going with this asymptotic result about the statistics. First, we propose. The first thing is this our proposed statistics is consistent. Okay. So how we prove that thing? It's basically simple to it's very simple. Only based on two observations. First one is this thing can be represent. This here star, the here star has can be represented in this way, and now based think what here has is basically an use statistic. So it's an unbiased estimator or consistent estimator here. So we are utilizing that this step, and we are also observing that the x bar for alpha 1 is a consistent estimator of mu to the power alpha. These two things basically help us to help us to say that our test statistics here start consistent. Okay, next we have find the asymptotic distribution under alternative, and this rooted into PR star and minus PR star. It follows asymptotic is basically what that it's asymptotic normal with mean 0 and variance in this particular form. And later under null we have calculated the variance. It's a big expression because of this general R. And this under null, we are getting the expression of the null variance is equal to this. And it's depends only on R. Okay. Now, now there, when we are calculating this null variance, we are considering the exponential lambda equals to 1. And that is because our test statistics is scaling. So we have this opportunity to take any lambda. That is the advantage to making the test statistics scaling variance. Okay. So now we will reject the null hypothesis. If rooted into the x star by this null variance is greater than equal to z alpha, right? So where the z alpha is the alpha is quantile of the standard normal random variance. In a similar manner, we can also we can also propose test procedure on the identity component. Thus, making the dimension of the inequality in the opposite direction. And by basically coming from the consideration that the DMPT were being lost, the inequality dimension was basically if this clear star so was positive. Okay. And this is what the ICT, what is happening, ICT will give you a negative. That's why this is it. Okay. Now to basically check the performance of our test statistics or compare the other test available in the literature, we have compared the performance in terms of the speedman asymptotic. For that thing, we have calculated first this speedman asymptotic efficiency. Then we have for this standard standard family of distribution like Telephone, Mecham, Pareto, and Whitewood. And these are the forms of the speedman asymptotic efficiency. And for different values of R, we have also calculated the numerical value of the speedman asymptotic efficiency. And then we have compared in terms of PAR with the existing test in the literature. And we have observed almost all the cases, our test perform better than all the competitors dedicated in the literature. Only one significant thing is this method proposed by Carl for the Mecham alternative far better than for basically all the alternatives, all the proposed tests available in the literature. Okay. And later we also did it. We also performed a simulation study to check the performance. Okay. So first, since we are saying that our test statistics is categorically normal, so small sample variation is not normal. So for that thing, we first calculated the quantile points for different sample size, and for different sample size, and basically these are the different quantile points that used for our test. This is for r equals to 0, and for r equals to 1 or 2 we have calculated. And similarly, in our paper, more things are given, but here I will not do. And later, next thing, we also calculated the empirical size of the test, and it shows it's basically empirical size is almost similar that we are expecting. For example, a 5% level of significance, that empirical type 1 error is basically very close to 5%. Okay, next we use the standard alternative like Y rule for checking the performance. For statistics, we use the standard alternative like Y rule, LFR, gamma, viscosity, and Pareto with different parameters, and these are the simulated results. And from there, few things we want to mention. So here, one thing I mentioned that initial state is for r equals to 0, and next state we will say for r equals to 1. If you just concentrate, then you will see that basically with r increasing, somehow few alternative, somehow r is decreasing, and the opposite thing is happening for some alternative. For example, this y rule, if you for y rule, the performance is increasing with r, but for the case of probably LFR or Pareto, it is basically decreasing. Yeah, for Pareto alternative, it's basically for r equals to 1, and for r equals to 1, for Pareto 1 it is 96%, but here for it is 97%. Although it is significantly smaller, but for decreasing it is very smaller. Okay, and few things I want to mention here that with the increasing of sample size, obviously the power is increasing, and from I will basically give another technique. So I also check the performance of our test which is completed, and there all the cases or at least 3 for here 4 everything completed our test perform data correspond to basically for all the alternatives. Yeah. Next we apply our this test procedure for different data set. First, we consider the data set, basically the data set reported in this paper, and this is basically the failure type or the mileage data of 19 military personnel carrier. And after applying this test procedure, this is the result. We are observing that so basically this data set is accepting the basically observing it saying that this data is coming from an exponential family or exponential distribution, and which agrees with the observation given in this article. Okay, and so one thing is, so here since it's coming from exponential family, so there is no advantage of adapting any equation policy or any equation policy. Okay, so next we also applied to particular data set. So that is one thing is this one. This data set is basically that indicate the number of revolutions of 10 million of 23 bond bearing. This data was first presented in this Babu data in this paper, and we also applied our text procedure for this data set, and if you reject the analysis of exponentiality, and it basically indicates that it's coming from the DAPDM alternative, and which exists with the observation in this paper. Okay, so I am speaking this, and yeah, okay. Before completing, so here we are proposing a family of test statistics based on R. So now view open view dimension of future one is there. So one thing is, although we are proposing basically a class of test statistics, but only what value of R will be significant, or what value of R is will perform better conformity all over. That kind of methodology is still not available in the literature, so one can explore that one. And here also we have extended our research procedure from the randomly license the data. So this is from the other type of interval sensor data or something that in future one can try to propose a method. Test procedure. Yeah, these are some references that I will. Okay, thank you.
Good afternoon. My topic is group symptoms. But as you said, it is very significant and very fundamental distinction between others. And that is why I decided to choose this topic. Since I am from international sector, instead I was feeling that I would like a percentage on percentage of statistics in this strategy of finance. But deliberately I have chosen this topic because of two reasons. One is that this conference is held in Kerala, and they are like funded by the people of Kerala. So at least we should do some work, but if possible, we should when we are doing the studies and research, I should present that we should try to do some contribution to the proper city. And sometimes it may not be possible, I come to that very and very different possible. But the second reason is that data. What is statistics? Statistics are about making inference from the data to help the organization to take right decisions to achieve their goals. So we have two parts of statistics. Just about data. If you don't have a quality data, then you will not be able to use your statistical technique. And the one reason that our statisticians are not able to use the statistics technique to provide the valuable insight to our government. Reasons are data is for the world. Always it is the way to find the data is for the world. I am going to address this issue. Okay. So data exchange, like a strategic asset or valuable assets for the organization, especially government, forever. And we had like from the independence, we have a planning department. Planning department defined that okay for the government programs, what is the data approach for the government? Then we define the sample surveys through the year. Statistics department of the government conducted surveys, collecting data, and then processing, analyze, and then we be valuable insight to the government. But all those things base are low. Now, really we struggle to get the data, but now the point is that we have plenty of data. Data is growing exponentially. We have plenty of data, but still we are not going to use them. That is our issue. This is my presentation. What we are trying to do. You know, something which is unique to the state government of Kerala or it is the universal issue. So I am just trying to address this issue and how this issue can be addressed having a data strategy. So what are the points we should consider while doing data study? The issues the state government is facing in the current administrative system, especially like the challenges which they are facing is like the data is generated every day, that is generated exponential rate. But what is going to happen? We have multiple systems. Unlike earlier, this data requirement goes from statistical department, so it will have a consistently. But now it is not like that. There are operational systems which generate the data. So operational systems are designed without any consultation with the statistics or planning department. As a result, we have multiple systems, and each system generates sometimes same data with individual difference. But the data which is common across the system, it may not be same. It will have the high come to this example. The second thing is like we have the privacy issues. Data is generated. We are able to store the data. In the study shows in Europe only 2% of the data generated by the government organizations will be stored. It's a valuable information, which may have a useful future if you analyze and see that what data is to take it. For example, total data is generated. Instead of deleting the data, you generate the key registers from that and store it. Look at you are converting a huge data into small sample. Valuable information historically different can analyze data. But this all involves a data strategy and involvement of statistics. So, what is a data strategy? So, data strategy should tell the government or any organization what data should be collected and how it should be collected and how it should be disseminated, how it should be used. Now, you can't have like each department is doing their own life. There has to be standard procedure. This is what it is. So, this data strategy become more important mainly because of this smart nation projects which are initiated in different parts of the world, even in India. And this smart governance is a part of this smart nation project. What is smart governance? So, smart governance is nothing but it is application of information technology and communication technology along with the data and statistical techniques to help the organization, especially government, to take decisions. So it's not necessarily that you always use statistical, but you need data to take decisions, small decisions. And so, for example, I will take that many including India, many countries have implemented this smart governance projects. For example, you have Singapore, I think almost all countries. In India, we have classical examples, we have our Aadhaar system. So, such data is collected and it is stored in centralized place, it is centralized. But the same data is used to delivering the government services in a more efficient way. But in India, only few services are linked to the other and the remaining are to running natural laws. But if you see the countries, other countries, for example, I am currently working in Tata, so I can tell you that same. For example, like COVID time. The government is able to identify the citizens who are high risk persons. Because they have their full information about your health status, medicines if you take, where you live, all information. So when there is a pandemic comes, when a disaster happens, government is able to just look at whatever analytics people, they are able to analyze and identify, okay, these are all the people who are high risk. They have diabetes or they have cholesterol and they take medicines and they will give. You didn't know that how many people are in the family, whether people are there to take care. So you have full information. They are able to take immediate decisions. You get a phone call saying that you are like a high risk person, you are supposed to take so and so today. And similarly, when the this case, like medicine case, vaccine case. Vaccine, there are no specific vaccine. Immediately they identify, okay, first lot of vaccine could go to so and so persons. Immediate cover. People are going to the, of course, the small country, but people are going to the households and giving the post-infected. If you see in Kerala, we had the national calamity recently in Wayanad. And even after so many days, they are not able to assess the losses, damage. And even in the first 24 hours, you can identify how many people are lost. Then how many lives. Now the question is that we have all the data. You provide the data about the buildings to the local panchayat or corporation, and you provide your personal details, your funding with details, everything, with their age, everything to the government for other, for protest list, for many purposes. But if you have this data, where is the household? In that household, how many people are living? Everything can be linked. Like, better. Government immediately after that. Okay, when the natural calamity happens, they know that okay, this many persons are living there, and these are living in this. You will be able to see in the dashboard in the map and see, and then detect, and then you will data. So this is not expected from the smart governance project. So this will improve the efficiency, inclusivity, transparency, and citizen satisfaction. And this helps the government in many ways. So I'm just going to describe. Now coming to Kerala, we have unlike the other countries, Kerala has just started the smart governance project. We have an advantage because this is the time we can correct it. If we go ahead with implementing many things and thereafter we say, no, this information is missing, this not be working with this and this is what we have done. So why I am presenting it, as a statistical community, we should take it up this with the government and try to get the data for training and so on. So we have something called e-save on it is a unified site where you are able to get, like, suppose you want the birth certificate, you enter the information together. You have the certificate. If you want to apply for a loan, you can get it done. If you want the income certificate, everything you are able to get it through this. But the problem is, other than something solved for. Now you have a digital workforce management system. So here what those who are looking for employment, they can go and register there. Then they will connect to the employer and similarly now we have a legal support. Between the problem that you go and register there, then if you are going to the government hospital, your information will be captured. If you are going to go to the private hospital, you will be missing for what is required? You have to have a strategy to collect the information of self-documented research, whether it is a government or private or then this whole set is collected with other information to be able to get a model. Then you have the personal affairs and how to support the government information. So these are information, but if you want to know how many employees are retiring in 2023, after your pension liability for the government for next 5 years, you can't post that. You don't have the data. Data is available somewhere, but it is not prepared, it is not accessible, it is not received. And now, one of the interesting something which is really like a smart, AI camera. Recently, the government is using AI camera integrated. It generates huge. It is something that's useful. It should do something that you want to do that as human beings. You do not want to identify the violations. But cameras are able to immediately generate and identify violations and the notification to the violator. Camera generate the data. You identify the vehicle. One of the details of one of the vehicle of the system. So these systems generate more and more information. So the question is that are we able to use this information to are we retaining this data? How long we are retaining that? Because overall, that's it. You are 30 years data. So can we retain this entire data for 30 years? Please know how do we agree it? What are the KPIs or metrics used to get those to compress data or try to reduce the dependency on data? Last question, whether data is accessible to translate process. Therefore, let's see. So, government is facing many challenges. This is our portal, one portal. There are many portals, and we are saying that many services are available. How many applications? I don't know how many portals, what is the efficiency of the government application. One of the challenges we are facing is data centers. Not available for physical data. Lack of consistency, integration association. When you are listing any building in process, you can learn from the government to see when you are clustering this information, along with the clustering geographic information, that's what the middle of the building. Then when you want to occupy in that building, you are going to begin the school in the government water, you are since your latitude and longitude are not available, you can collect all the information. What is it? What is the
IAS system. Those people are put in charge of various departments. Some of them are fully ignorant, some of them don't care, and the rest, all of them are busy with meeting after meeting. Even if they have some brain to think over something, they have no time to think over something and execute. So those are the fellows who are supposed to execute all these activities. And they are not going to execute any of them, are not capable of doing any of them. So you can suggest whatever you want, you can discuss, you can formulate a policy, nothing is going to be implemented, nothing is going to be executed. I have checked data collection system in 80 districts. When I was visiting the 80 district, they found that my continuance would be dangerous for 2,000 people. So it was stopped. So I finally had to give up. This is the situation. Unless the basic structure changes, nothing is going to happen. We can spend a lot of money. You have a lot of data. I have conducted large scale surveys, implemented 3 to 4 major projects. One project was road foundation project executed by Professor William Law. It was in the early 1960s. I was part of the team analyzing the data. Finally, we found that the whole data was bogus. They collected by 40 people in Kerala, 1960s. So the whole project had to be abandoned. We had another project, DST project on crop estimate. Huge amount of money was spent by the government. Finally, we found that whatever data we have, data are copied from the state data and also from meteorological station. Finally, we found that data was fully bogus. I conducted so many tests on them. Crop estimation data available. Crop cultivation, acreage of cultivated land, all those things are available in the government. You can go and take the data right now and conduct some of the statistical tests and see whether there is any significant difference between a particular item, say copper, when the land is irrigated or not irrigated. You will find it. The fertilizer is put or no.
Advances in computing power and the refinement of techniques like Markov-Chain Monte Carlo have enabled efficient handling of high-dimensional Bayesian models. By incorporating spatial random effects with a condition overfluously driver, regions and periods of increased disease illness can be identified, uncovering patterns that persist or change over time. Various approaches have been proposed to model these trends, such as the imaginary Eckhart, Norris, Lawson, Leon Lawson, and Ashworth. In our study, we compare three basic spatial models for effectively capturing the relative risk of breast cancer incidence. Kerala's capital, Thiruvananthapuram, is one of the major cities in India having a very high incidence rate with an ASR of 35.6 and a higher crude incidence rate of 47 showed a significant increase by 5.1% annually. Breast cancer accounts for 31% of all cancers among females in Thiruvananthapuram. Breast cancer is influenced by several well-established factors including aging population, changes in reproductive patterns, and lifestyle transitions, etc. Recently, some studies suggesting an association between outdoor air pollution and breast cancer risk. In this study, we aim to investigate the association between air pollution and breast cancer incidence through BST approach based on data from population-based cancer registry Thiruvananthapuram. The objective of my study is to characterize the spatial pattern of disease incidence to compare various patient-centered models and to assess the association between breast cancer and air pollutants. The study area I selected is the Thiruvananthapuram Taluk, comprising of 29 administrative units and a temporal aggregation of 3 years, mainly 2005, 7, 8, and up to 17, 19. In total of 4370 breast cancer cases are reported at PBCR were collected. The air pollution data obtained from Kerala State Pollution Control Board and population density were also used as a correlates. The collected data were then geocoded using Google software and polluter concentrations at unmonitored locations were estimated. The boundaries in the study area were sourced from Diwaji's database as shapefiles. ArcGIS and SATSCAN software were used for the space-time analysis and R software for spatial-temporal modeling. First, I have investigated the existence of spatial clusters in the study area. For this, I have used global and local spatial autocorrelation measures. Here, global modern and anti-local modern both are used to determine the existence of significant spatial clusters and to assess the degree of spatial autocorrelation. Then, degrees of generality statistic is used to determine whether the observed clusters were of high or low values. Then, degrees of general GI star statistic is used to perform hotspot analysis to identify the exact locations of the clusters obtained. Then, full-blown space-time scan statistical analysis using SATSCAN was used to detect the temporal and space-time clusters. The discrete Poisson probability model was used since our disease count is used. The window with maximum LLR is defined as the most likely cluster area, and with statistically significant log likelihood ratios were defined as the secondary potential clusters. Before moving to spatial-temporal modeling, an initial Poisson generalized linear model was performed to study the effects of available coordinates in assessing spatial-temporal autocorrelation. Here, the study region is partitioned into 29 overlapping area units, and data are obtained for each unit for 5 consecutive time periods. Here, the response data denoted by the vector y, which follows Poisson with expected from EKT and with the risk theta pt. The general form of Bayesian spatial-temporal model is given by y follows Poisson theta pt, where theta kt is modeled as ln theta kt equal to x kt transpose beta OKT plus psi kt. Here, OKT is known as offset. Psi kt denotes the random effect combining components that capture spatial, temporal, and space-time interactions. Different structures for psi kt have given the creation of diverse spatial-temporal models. The goal of this study is to estimate the extent to which the spatial variation in response has changed over time. Hence, we have applied 3 Bayesian spatial-temporal models, namely BST-CAR, first-order autoregressive, second-order autoregressive, and separated spatial models. Here, CAR is incorporated for spatial-temporal random effect, where the temporal correlation is modeled through an autoregressive mean decomposition and spatial correlation by the precision metrics. These are the overview of my model. Here, AR1 and AR2 model, the spatial-temporal structure is used to estimate the evolution of the spatial random method surface over time. The separable model contains an additional term denoted by delta T to estimate an overall temporal trend. The results of my study are 4370 female breast cancers were observed during the study period with a crude rates of 36.82, 43, etc. up to 60.78 for each study period respectively, and an average of 52% of administrative units had rates exceeding 50 throughout the period. However, the distribution of BC varied greatly between administrative units, ranging from 0 to as high as greater than 90 each year. The urban areas with a high incidence rate showed a significant trend increase from 41.76 in 2005-7 to 72.31 in 2008-10. For expert spatial data analysis, we first mapped the spatial distribution of breast cancer incidence. The graph itself showed an increasing trend over the years with a higher rate concentrated in urban areas as mentioned in the population census. The global model size and generally effects of results are given here. From the global model size result, it is clear that hotspot analysis located high-risk clusters in urban areas with relatively high relative risk. These are the result of hotspot analysis. Most of the hotspots, that is high values surrounded by high values, were located in urban regions. SATSAN result also gives the same. Then the result of Poisson generalized linear model is that all the covariates have significant effect on breast cancer incidence. To quantify the presence of spatial autocorrelation in the residuals, we compute a modern-sized statistics of the residuals. Then all three models are running R programming using R-based package using NCNC with 2 lakh something iterations. Then these are the results I have obtained. Of those models, BSC car ARR model had substantially better fit as demonstrated by the smallest DIC and WIC. Then BSC car separate station model had the largest DIC and WIC. The estimated relative risk based on AR1 value is summarized in the figure below. From figure, it is noticeable that relative risk showed an increasing trend in BC incidence, with urban area showed the highest relative risk in each year investigated. Based on spatial autocorrelation techniques, we observed significant global spatial autocorrelation indicating clustered pattern of BC incidence with hotspot analysis identifying high-risk clusters predominantly in urban regions. Among different BSC car model tested, the AR1 model emerged as a best fit, effectively capturing spatial variation BC incidence and identifying high-risk areas. By analyzing disease patterns over time, we observed an upward trend in the risk of BC incidence with significant association with air pollutants such as PM2.5 and NO2, and urban areas consistently showing the highest relative risk annually. In conclusion, this study demonstrates the effectiveness of BST modeling techniques for risk estimation in addressing both spatial and temporal effects in BC incidence. Further studies are needed to validate these findings across diverse populations, explore causal mechanisms, and assess the impact of other risk factors on BC risk. Thank you.
Any question? In the competition, only the judges will ask the question. If audience is given the opportunity, bias will be created. So no question from the audience, only audience from the examiners.
This paper identified particular manner and responsible incidents in a large prospective US cohort study conducted in 2024. Then 24.
Some benchmarking, some benchmarking, right?
But these two studies specifically saying about these particular matters in direction after breast cancer. No, by exact biological reason was remains unclear. We already said that, but some kind of these pollutants will induce some oxidative stress inflammations inside our body, and this will accumulate over time and will cause breast cancer. Breast cancer density is one of the main factors in breast cancer. So some studies have found that this difference may result in increase in breast cancer density.
It's no question or comment from the.
For the other state like Delhi, Delhi is the most polluted state, right? Yes. Will you travel there?
No, sir. No, sir. Because of the availability of data itself is a reason. I just collected the breast cancer incident data from population-based cancer center Thiruvananthapuram from Avigal Cancer Center. So my study is limited to my study area Thiruvananthapuram Valley. Thanks, ma'am. Okay, thanks. Yes, sir. No, sir, these were already. Yes, sir. Yes, sir. There's somewhere.
The possession and thank you for running through the exhibition. We'll move on to the next.
Thank you, sir.
Now, next presenter is Satyanarayana, and he will be presenting on topic empirical likelihood, registered empirical likelihood and the empirical likelihood process of the molecular governance test. Good evening. My name is Satyanarayana. I'm going to present my research work on empirical likelihood, adjusted empirical likelihood version of Leibniz test. So we know that in applied research, Leibniz test is the most commonly used test for testing the equality of variance among k independent normal for distribution. So this assumption is one of the important assumptions for both one-way ANOVA as well as the regression analysis. Because Bartlett was found was like the foundation and condition accurate ratio test. So he has also introduced or mentioned the theoretical justification why we need to conditional test, even though the Bartlett test is sensitive to the normality assumption. So later, Levy in 1960 has proposed a test for equality of variance. It was later modified by Brown and Prost, call it as modified Leibniz test. So we know that both Leibniz test as well as the modified Leibniz version will have the estimated type on a rate which is lesser than the nominal. So in other ways, Owen has introduced empirical likelihood ratio test, which has been gained a lot of importance because of the non-parametric nature. So it has been estimated both for the regression as well as the inference version. So we have introduced two empirical likelihood ratio tests already. One is for the David-Fisher problem, and one we have introduced empirical likelihood ratio test for autocorrelation and linear regression model. Now, main motivation for this work is the EM version is distortion free and it has better performance in maintaining the size as well as the good power. So that in this paper we have introduced empirical likelihood version as well as the adjusted empirical likelihood version of Leibniz test as well as the modified Leibniz test. And we have compared with Bartlett, Leibniz test, modified Leibniz test and the lowest test. We under both normal condition and the non-normal models. We also find out what is the minimum sample size we need to maintain the study. So this is the methodology. So this is the hypothesis of interest, equality of variance among the k, where Z is the denote the absolute deviation taken from either mean or the median. So we have compared with these four tests, where whole exact test is equal to the modified Leibniz test only, but the only thing is the exact test statistics is derived from the parametric bootstrap. So this is the proposed empirical likelihood maximizing the product NIPAJ subject to this condition. We have the theorem under regularity condition. We have proved that asymptotic null distribution of the empirical likelihood ratio test statistic follows chi-square with k degrees of freedom. So this is the rough sketch of the proof. So one of the problems of empirical likelihood ratio test is when the convex hull does not contain the true hypothesized value, we are not getting the feasible solution. So Owen has mentioned that in this case, when you are not getting the feasible solution, we have to reject the null hypothesis. When we reject the null hypothesis, it will increase the I1 error rate. So one of the other challenges, it will have the usual unadjusted empirical likelihood ratio will have the slow convergence rate. So based on which, Chen et al. In 2008 has introduced the adjusted empirical likelihood ratio approach. According to this approach, data will be appended with the artificial observation. So now we are working with the not n observation, n plus 1 observation. So the specialty of adding the artificial observation will be that it will redefine the convex curve such that it will contain the true parameters. So despite the inclusion of additional observation also, the adjusted empirical likelihood ratio test statistics also follows the original chi-square with k minus 1 degree separate. So this is the test statistics of adjusted empirical likelihood ratio test, which is similar to the unadjusted, but we are working with the n plus 1 observation. So next, the obvious question is, what should be the n plus 1 observation? So for the n plus 1 observation, we take minus an into zi dot bar. So one of the solutions for an as also given by the Chen et al. We can take an as 1 by 2 log of n. So similarly, we are having the theorem 2, that is adjusted empirical likelihood. That is also follows chi-square with the k minus 1 degree separate. So this is the simulation setup. We have considered the simulation setup as given by the Ching et al. So we have considered the number of group as 3,000 application, and we took nominal as 5%. To vary the sample size, we have considered equation 3. We have considered the relative sample size starting from 446 to 50, 50, 75. We have included both equal as well as the unequal sample size. To vary the variances under alternative to conclude this power, we have considered equation 4. We have considered the variety of variance with respect to epsilon. Epsilon is taken from 0.1 to 2 to cover low, medium, as well as the high variance. So this is the sample size computation under normal distribution. You can see that when the sample size is very less, for less than 12, so Bartlett test as well as the Leibniz test will maintain the size. You can see that when the sample size crosses 20, the proposed empirical likelihood version, both adjusted as well as the unadjusted version, will maintain the size better. So the same is also observed when we deal with the equal probability, so equal sample size. So this is the problem where n equal to 12. You can see that even though empirical likelihood power is high, but when n equal to 12, it does not maintain the size. So we will recommend the Bartlett as well as the Leibniz test. So this is the power when n equal to 24. This is equal to 30, where all the 4 proposed empirical likelihood tests will have a better power compared to the remaining, especially the empirical likelihood version of the modified Leibniz test. So then we went for identifying the robustness of the proposed test. We have verified under gamma distribution the same pattern. This is the size and power. We have verified with the pre-distribution. This is the power. So then we have calculated what should be the sample size, minimum sample size required to maintain the nominal level. For adjusted empirical likelihood, it is 20, and for the non-normal distribution, it is 24. So then we thought of identifying what should be the final sample property, because asymptotically followed chi-square with k minus 1 degree separate. What should be the small sample property? For that, we have computed the first 4 sample. So based on the skewness and kurtosis, most of the basal skewness kurtosis, it will follow Pearson family of and full distribution. Later, we have also verified with real-life example. Consider our 4 group analysis. This was data collected by 1991 by FOA. So this group has this data has 4 groups. First, we check for the normality assumption. So the data follows normality. Then we applied all the 4 tests, all the 8 tests available. So all the tests confirm that there is a variance are not equal. So there is a variation among the treatment. So all the conclusions say that proposed empirical likelihood test is asymptotically distribution free. So for when the normality assumption is satisfied, we can use Bartlett as well as the Leibniz test. But when the sample size is equal to 20 or more than 20, we can go for empirical likelihood function. So whenever the non-normal data, more tests can be applied for the small samples. And when the sample is greater than 24, we can apply the empirical likelihood and the empirical likelihood function. We can see that lastly, so empirical likelihood function, even though it has the size is more liberal, that means more than the nominal level, but layman and Emerson suggestion that better to use the test which is liberal but has the more power compared to the test which has a smaller nominal level and less number. So that we suggested for recommended the empirical version of revenue test, especially the listed empirical likelihood ratio test of the variance. So these are the sample paper I have referred. Thank you. So in the usual empirical, unadjusted empirical approach, the problem is it will not converge. So we are most of the time we will get the infeasible solution. So the iteration will keep on continuing. It will take a longer time. Most of the time we will get an infeasible solution. So that's why we are waiting for the adjusted empirical version. So this problem is also mentioned in the Chen et al. Paper. So that's why they have introduced the unadjusted empirical version.
We make a statement that asymptotically distribution is free.
So empirical account?
No, what's the meaning of asymptotically distribution free?
So asymptotically, so in a sense, the like empirical account ratio test does not depend on the distribution assumption.
It goes to constant. Does it go to a constant?
Not surely. So that means it does not assume that any will come from any particular parental population or populated distribution. So that's why it's a non-parametric question.
You have a theorem about asymptotic chi-square.
Yes.
Can you give an outline of the proof? Just a few steps. You have two theorems, these statements.
Yes. So this one, if we assume that Zi, we refer the mean of Zi as given. So this will convert this to Z bar. So Z bar as the overall mean. So that the product Ni into Zi dot minus Z bar whole square. So that will become the treatment sum of square in the NO version. So that treatment sum of square divided by the sigma square will follow chi-square with k minus 1 degrees of freedom. So the simplified version of 2 minus 2 log empirical angular version also follows the same. So that we conclude that it is chi-square with k minus 1 degrees of freedom.
Now, next presenter, Divya Dennis. She will be making the procedures on simultaneous warming of heterogeneity in relational and trajectories and multiple time to event.
And Divya Dennis, research scholar, Division for Cancer Epidemiology and Biostatistics, Regional Cancer Center, India. This is the overview of my presentation. Colorectal cancer is the third most cancer in India, as well as globally, and second leading cause of mortality. Hence, we look into the survival of the colon cancer patient data. Usually, the cancer survivor, the patients were observed over time, and the multiple events were observed during the period, such as when a patient is diagnosed as cancer, the patient will follow till the treatment, and that treatment process, the patient may have experienced several events like recurrence, metastasis, death, etc. While carrying out this clinical analysis in colon cancer over the follow-up period, the repeatedly measured covariate, that is carcinoembryonic antigen, taken over the period. So the survival outcomes depend on this longitudinal measured CA value. So this model, we should think about the modeling of longitudinal measure and multiple event jointly to get more reliable survival estimate, which leads to the joint multi-state model. And going to the introduction, the joint multi-state model combined with the two submodels, that is longitudinal submodel and the multi-state submodel. Usually, these multiple events are estimated separately. To get the reliable estimate, the simultaneous estimation is needed. So the existing model, multi-state model, is simultaneously estimate the events. And going to the joint model concept, several joint model exist in literature, but the joint multi-state concept, there is some literature have. Apart from that, our work is to identify the unobserved random heterogeneity existing between these multiple events. So the incorporation of these multiple events, the unobserved random heterogeneity is called priority to the multi-state part. And in the joint model concept, we also measure the unobserved, measure the repeatedly measured covariate also. So jointly modeling these two submodels, we introduce the joint multi-state priority model. In the proposed model, the longitudinal measured covariate were fitted using linear mixed model, and the multiple events were modeled using multi-state priority model. We assume the priority parameter to follow the gamma distribution. This is the multi-state diagram. Here, when the patient is diagnosed as cancer, they go to the locoregional recurrence, metastasis, and finally the absorbing state death. Apart from that, we also consider the longitudinal measured covariate also. And here is the methodology part. And for the individual eye, the longitudinal process and the multi-state process were observed. And it is the multi-state process, change in time, and delta KL as the indicator. The genesis of joint multi-state model, the equation 1 represents the longitudinal submodel. And here, these are the continuous metrics, and ZIF, we are independent of each other. And the multi-state model is given in equation number 2, and the WKL is the transition specific association value that linked between the two models. And here WKL can be defined as the true level of the marker and the current slope or current intercept or any other function of the randomity. Here, each of these quantifies the impact of the longitudinal marker dynamic on the transition intensity between the states K and L. And here is the proposed model. We incorporate the priority parameter, priority to the joint multi-state model, and we get this joint multi-state priority model. The estimation part, here is the complete likelihood is given in equation number 4. It is the multiplicative of the longitudinal submodel and the multi-state submodel and the random effect. The equation 7 represents the multi-state subpart of the joint multi-state model. So the incorporation of the priority, we get the likelihood, we get the multi-state part of the equation 8. And substituting the equation 5, 6, 9, and 4, we get the complete likelihood of the joint multi-state priority model. Here, we consider the expectation maximization algorithm by considering the random effect as the missing values. And U step is given 10 and L step is given 11. By the iterative procedure, we estimate the parameter using R. And next we go to the application. For the illustration, we consider the data set of 343 patients of colon cancer registered in regional cancer during the prayer. And the longitudinal variable is CA value, and the covariates were used to aid the sex composite stage, lymph node involvement, LDT for comorbidity, etc. Here we consider 4 different state of transitions. And here's the longitudinal trajectories of the CA values. And the table will represent the parameter estimate of the longitudinal process. For the all transition, we observe that the composite stage is the only parameter shows a significant value. And going to the hazard ratio, we estimate all the transition specific hazard and also the coefficient associated value and frequency parameter. Here, the transition from 1 to 2, that is transition from diagnosed as to recurrence, we show the it has show the significance also. The key for and increase significantly joint multi-stage model, and in transition from 1 to 3, the composite stage is also significant. And in transition from 1 to 4, PNA shows the significance. And in transition 2 to 4, composite stage and 3 to 4, composite stage is also significant. And in all the transition, we saw that the priority parameters show the significant value. This is the dynamic survival probability prediction. We randomly choose a person for a subject 14, and the corresponding to the CA value, the vertical line shows the last point of the CA value collected, and we predict the survival. And from 1 to 2, and transition from diagnosed to recurrence, and all transition, the survival has high compared to transition from 1 to 4. And this is the model identification using the information criteria AC, BAC, ACC. So the joint multi-stage priority model shows the preferred and the summary. The present study we derived the four-stage joint multi-stage model. The proposed model was helpful in predicting the multiple events and longitudinal measure CA values simultaneously in the presence of random probability factor. That according to the colon cancer data, the composite stage PNA, LV, TILCO along with the longitudinally measured CA value were found to be a significant prognostic factor, and the predictive parameter was significant. Thus, we conclude that joint multi-stage predictive model as the better model for the simultaneous prediction of multiple events in the presence of the random probability. Further analysis.
I have some 4 objects listed. What is your contribution here? In your slide, there are 4 objects, including you, in the beginning.
One of my guys.
So, yeah, who are the other 2?
Actually, this is only 3.
Including you, only 3?
Yes.
Okay, who is the other one?
Who is the other one? He's helping to the analysis part for the calling section.
So your contribution is what?
No, we both are working in joint model. Actually, I'm working on the multi-state part, and he's working on the only survival outcome. So we both are doing the same concept. So we.
Recording this multi-stage system. Yes. Right. So, can you explain how these multi-stage systems are basically effective in your main study? Basically, while you are defining the model, right? Yes. How you are incorporating that multi-stage thing in your model?
Yeah, I also.
How you are incorporating that? Can you?
Yeah. In equation 3, the first is the linear mixed model, and the next second is the joint multi-stage model. Here is the W is the association value that depends between the longitudinal and the multi-stage process.
So, for example, if something is from state 1 to state 2, it's jumping. Yes, that way will be decided that thing, right? Or what is the how they will be affecting the model. For example, you are direct there, how it's switching from what basically state 2 to state 3 or state 2 to state 2, right? Yes. So how that thing is incorporated in your model?
Actually, the multi-state in this concept, we longitudinally measure some covariate for all the patients. That covariate have an effect for these multiple transitions. So this jointly model, there is any association we get, we can say that the value will depend on the patient survival for the different type of events.
Thank you for your presentation. Now in this session, we have one more presenter, Haripriya. She will be presenting a topic called the FSC approach to this one, contributes 20 days estimated. This means this.
Good evening to one and all present here. Myself, Haripriya, PhD Research Scholar, Department of Statistics, Bharatiya University, Coimbatore, under the guidance of Dr. Raj Jaishankar, Professor and Head, Department of Statistics, Bharatiya University. My topic is a fuzzy approach to calculate fish strength estimator. We can call it as KP estimator. This is my abstract. And in introduction, the importance of the subject survival analysis came from the fact that it analyzes the data concerned with the lifetimes of the living beings. Though lifetimes are random variables which can be characterized by some probability distribution, a major hurdle for analyzing survival data is the problem of censoring, because of which the scientists prefer non-parametric methods. One among such methods is due to Kaplan-Meier in 1958 is most familiar, which could be used in case of heavily censored data and estimate the survival function by means of the conditional probabilities, which are obtained based on the censored and observed events. With the assumption of independence of censored and survival times, non-informative, sensory, and homogeneity of risk. Nelson Allen in 1972 proposed another non-parametric estimator which estimates the cumulative hazard function. The main drawback of these estimators is that they could not incorporate the covariance. Cox in 1972 has suggested a procedure for estimating the hazard function based on the proportional hazard assumption and linear relationships with the covariance. Breslau in 1972 suggested a formula which could be used as a baseline hazard function in the Cox regression model. The Breslau model works well for large data sets with a few times and even times are approximately continuous. However, it is not suitable when the types are more frequent and even times are very discrete. It may introduce bias in such situations. To overcome these limitations, Calvin-Flisch Prentice in 1980 proposed an alternative for estimating the baseline hazard function which works well even with smaller data and frequent times. In survival data, the survival times are mostly continuous in many cases. However, they are recorded as discrete more often. It is evident that the continuous observations are more or less fuzzy, and the same is also applicable to the survival times written in 2011. When the survival times are influenced by certain covariates of continuous in nature, they may also be considered as fuzzy. Hence, apart from randomness, the fuzziness present in the data should also be accounted and addressed in order to get more reliable survival or hazard estimates. In this work, an approach is suggested to incorporate fuzziness in KP estimator. So here is the formula for the KP estimator. We are using it for the baseline survival function. In this estimator, the events, particularly the KP estimator, considers in handling types. But in this work, we are just doing a fuzziness for the given data and doing analysis using the KP estimator. So methodology, let T1, T2, etc. Tm represents the survival times of m subjects taken in a study. As stated earlier, the survival times are continuous in nature but recorded as discrete quantities and hence they are more or less fuzzy. In the first step, the survival times are converted into triangular fuzzy numbers with a specified classification factor. The triangular fuzzy numbers are more commonly used fuzzy numbers which mainly have 3 points. It is minimum possible value and the most likely value and finding the maximum possible value. A similar procedure of classification numbers is to be adopted for the covariates which are continuous in nature by converting them also into triangular fuzzy numbers. So in fuzzy numbers, we should adapt a membership function. Here we consider the mu del I of t of the first survival times that assigns a degree of membership to each time of that point, which ranges from 0 to 1, where 0 indicates no membership and 1 indicates full membership. The classified survival time delta A can be represented together with the membership first set as follows. After converting the survival times as well as the continuous covariates as fuzzy numbers, the alpha cuts of each of them for a specified level of alpha were found. A crisp interval, alpha cut means it's a crisp interval which contains all the points with a membership degree greater than or equal to alpha. But the value of alpha ranges from 0 to 1 is the alpha cuts of that particular fuzzy number. The alpha cut of this given survival time can be represented as follows. After converting to fuzzy numbers, we are doing declassification using the centroid method, that is center of gravity method. So also the case, the classified covariance of the model was that using the declassified values, the KP estimator was calculated with the help of Python software, and the results obtained may be combined with the classical KP estimator. So I have taken a numerical illustration. It is a diagram which represents the self-reported time in weeks of the occurrence of relapse or the time at which the patient was lost to follow-up, and patient status was mentioned. The drug of choice they have taken, and the patient's age was also taken as an additional covariate. So the baseline hazard function and the baseline survival function for the falsified KP estimator is tabulated as follows. The graphical representation for both the classical KP estimator and falsified KP estimator of the baseline survival and baseline hazard functions are given. The median survival values for the classical and falsified KP estimator is shown. It shows the difference itself. In classical approach, we have median survival time as 40.3914, and in falsified approach, it is 34.90. So, in the table as well as the graphs corresponding to the values of the hazard and survival, significant difference were observed while comparing the results of classical methodology and falsified methodology. As it is the case, the median survival time differs. It takes the value 40.39.14 in classical KP estimator and 34.9063 in falsified KP estimator. This difference seems to be significant difference and hence cannot be omitted. Conclusion. When a statistical analysis is conducted using data from a random sample, it is crucial to take into account both the randomness and the fuzziness of the data, especially when the data are continuous. The estimate of survival probabilities and survival curves exhibit differences when classification is considered in the context of KP estimator. The results often can be regarded as more reliable due to the consideration of the fundamental nature of fuzziness and also randomness. Although the type of survival data, the event, and the researcher's viewpoint should also be taken into consideration when choosing the classification factor in the case. These are my references. Thank you. The person is value substitution. He takes the value before and after patient. If you have time to, if a patient is died at the time, particular time point, maybe before or after, if one is to say exact time. The CD will show some kind of parameter. So we are taking it before and after that. Actually, I understand how in this particular exam is everything kind of different. We are looking forward to do more on this. It's going to be around 19 hours.
You have a statement somewhere, something significant. How did you check it? Somewhere you have something significant. significant importance. How many jobs?
Actually, we have also done the
How will you do it?
That is already depends on your this part. So we qualify and apply will be different. The thing is why you are considering only cellular party number or something. So there is any cellular party number, it can be nowadays many things are coming. Okay, another thing. So in the beginning you told that informative sensory. Informative sensory, right? So informative sensory and non-informative sensory, right? Two types of things are there. Can you give one example for it? One context. Only for the non-informative sensory.
She comes on the after last 3 months, maybe she went to her mother's house. So the particular study is going lost some kind of
I would like to thank all the presenters of this.
Thanks. Thank you, sir. Now we are moving to another section, which is a contributory section that is also chaired by Dr. Nama Selanity. Over to you, sir.
Yeah. In this session, again, we have three presentations, and this again it is 40 minutes. So, I think, just like in the last presentation, every participant is able to take only 8 minutes. So try to stick to the timing, and we will start now. The first presentation is from Sachin Acharya. The topic is performance of classification models in extremely imbalanced multi-class data.
Good evening all, myself Sachin Acharya. I am going to present my research topic, the performance of classification model in extremely imbalanced multi-class data. So we'll have a brief introduction to the topic. So classification is a machine learning technique that involves the prediction of unknown class label of a given observation. So class imbalance is a common issue in the classification task where one class is significantly underrepresented when compared to the other class. Here the underrepresented class is called the minority class and other class is called the majority class. Then it leads to the drastic impact on the performance of the classification model. So in real life scenario, we can see some class imbalance instances like fraud detection, spam filtering, and multiple diagnosis, etc. So here, the class imbalance is defined based on the ratio of majority to minority class instances. Here, the class is said to be imbalanced if the ratio of minority to majority is 1:4, according to the binary account. And here, this table represents the definitions given to the extreme imbalance ratio by various authors. And Levy et al. 2018, he defines if the majority to minority ratio is between 100:1 and 10,000:1. In that case, we consider extremely imbalanced setting. So initially, the multi-class problems were tackled by converting them into binary class problems using the binarization strategy. So there are two binarization strategies, that is one versus one and another one versus or. So here one versus one strategy divides the m class into m into m minus 1 by 2 binary class problem, whereas OVA strategy subdivides the m class into m binary class subproblems. So in many of these methods, in many cases, these methods struggle when data contains the extreme class imbalance. So where we'll have the biased prediction towards the majority class. There are data balancing techniques such as undersampling and oversampling techniques, which aim to address this issue of class imbalance, either by removing the current instances or by generating the new instances. So balancing the classification using these techniques may improve the performance of the classification model. But when it comes to the real life scenario, it alters in terms of performance. And Young et al. Highly recommended not to use the undersampling and oversampling technique for predicting the for prediction models in large data sets, especially in the case of health domain. So with this background, we observe that there is a need for the study for evaluating the performance of various classification models in case of extremely imbalanced data because of any balancing technique. With this, we have considered different classification models in our methodology. So HM is the one first classification model which is applicable for both linear and non-linear data. So what it does is it searches for the linear optimal separating hyperplane such that there is a clear cut separation between the classes. The second one is K nearest neighborhood classifier. So here it classifies by comparing the given test data with the K nearest neighbor, the training data set, and label of the majority label of the training data are assigned to the test data. So decision tree, one more classifier is decision tree, where it is tree-like structure used for both classification as well as regression tasks. So the structure resembles flow chart where internal node represents the text on the attribute, branches with the outcomes of the test, and leaf nodes holds the class labels. So another one is random forest. It is an example method, and it uses the multiple decision tree as a classifier, and it classifies based on the majority of votes from each state. Another classifier we have considered is many-based classifier, where it classifies the given tuple based on the highest possible probability. And the performance of these classification models are evaluated using the evaluation metrics, like accuracy of each classes and the symmetric mean. So this is a simulation study, and it's a reference from the article from in 2017. Here the data is generated from the multinomial verification model. Number of classes considered are 3, and in which the one is majority class and 2 minority class. And independent variables considered are 4 and 8. The classification methods are SL, SVM, KMN, distantly, random forest and Bayesian classifier. Performance measures plus used are fast accuracy and genetic mean of recall. And sample sizes varies from 100 to 200 with the increment of 20 and 250 sample sizes considered. And imbalance ratio varies from 3 to 6 with an increment of 0.5, which is a definition given by Stefan from an upper power extremely imbalanced data. So the distribution of the data is varied from normal phenomenon distribution and distribution is 1 degree of freedom, and we are looking in exponential distribution and uniform distribution as well. And the simulation is repeated 5% times. So this is the result of the class accuracy for the number of variables equal to 4 and distribution is standard normal distribution. And here you can observe the sample size is varied from 100 to 250, and imbalance ratio we got it considered 3, 5, and 6. And performance measure is considered here is class wise accuracy, and we can observe that the class as we consider the accuracy of each class together, SVM performs better for this considered K value and definition, and we can observe here the class 2 accuracy when the sample size is 100 and the class 2 accuracy decreases as we increase the imbalance issue with a small proportion. So here it is 80%. When it comes to imbalance ratio, 6, it will become 81%. Similar kind of results can be seen here by varying the text when we vary the textual efficiency. So here also the decision tree performs better. The class accuracy when we consider for the K equal to 8 and the distribution is standard normal distribution, here also SVM performs better. And here the distribution as textual distribution is 1 degrees of freedom. Here we can see that SVM performs better, as well as we can observe that for the sample size 120, the class 2 accuracy is 45%, and as the imbalance ratio increases, it is reduced to 29%. There is a drastic reduction in the performance in the class accuracy. So this is a plot of geometric mean for the classification model for K equal to 4 and distribution and normal distribution, and we can observe that there is a SVM and KNN are the best of classification model, and as the imbalance ratio increases, there is a decrease in the performance of the class. So this is for the similar for texture with 1 degrees of freedom, and this is for the K equal to 8 and standard normal distribution, and this is for the K equal to 8 and texture with 1 degree of freedom. So we have considered a great application. Here we have considered so here also we observe that SVM performs better, which is decision tree performs better, which is followed by the SVM. And the overall conclusion is that as the level of class imbalance, sample size, number of variables, and distribution affect the performance of classification model. Under normal distribution, irrespective of the number of variables, SVM and KN performs better. And under non-normal distribution, efficiency followed by SVM performs better in case of small number of variables. SVM followed by KN perform better in case of large number of variables. And we have observed that there is SVM has comparatively higher accuracy than KN. This can be seen in the real example as well. These are the references. Distribution of the independent. Yes, yes. For the first model, all of them are normal and all of them.
Now we are on to the next session. This question is from this presentation is from Kartika Ramakrishna, and the topic is a novel, robust, weighted generalized new regression procedure for predictive modeling.
distribution properties in normal robust weighted generalize the mean regression procedure for predictive modeling. So this is my abstract. Regression analysis is widely utilized in statistical research for both estimation and prediction purposes. To address multicollinearity and outliers in classical linear regression models, LIU and robust LIU estimators were developed. This paper introduced a robust weighted generalized LIU estimator designed to simultaneously address these issues. When both multicollinearity and outliers are present, the performances of least squares LIU and RWGL estimators are evaluated using mean square error criterion under real and simulated environments. Activity information criterion for model selection and R-squared values for the above mentioned methods are also calculated. So, based on these measures, the study concludes that the robust weighted generalized lead estimator outperforms the other regression methods in datasets affected by both multiple linearity and outliers. So this is the introduction. The least square estimator is frequently utilized to predict the parameters of a regression model, provided that all the assumptions of the model are fully satisfied. Multicollinearity and outliers are the two important problems which often plague the researchers using regression methods. There are classical and robust regression methods developed for dealing these problems. Least square ridge leave are some of the regression methods applied to get a better estimator in the presence of both multicollinearity and outliers. This research described a novel, robust weighted generalized leave regression estimator for both real and simulated datasets, and for comparing the accuracy, the mean squared error, AIC, and R squared values are calculated. So, multicollinearity is a statistical concept where several independent variables in a model are correlated. The concept was developed by Farrer and Glover in 1967. Normally, two variables are said to be perfectly collinear if their correlation coefficient is plus or minus 1. Multicollinearity among independent variables will result in less reliable statistical inferences. The statistical technique called variance inflation factor can detect and measure the amount of collinearity in a multiple regression model. A VAF value of 1 indicates that the variables are not correlated. A VAF between 1 and 10 shows that the variables are moderately correlated, and a VAF greater than 10 demonstrates that the variables are highly correlated. Outliers are the values that look different from the other values in a dataset. Outliers are important because they can have large influence on statistics derived from the dataset. The detection of outlier is important for learning a robust and generalized machine learning system. To detect and remove the effect of outliers from the dataset, coexistence procedure is commonly used in the case of regression analysis. Typically, observations with a Cook distance greater than 4 times the mean are considered influential. Examine influential observations to determine if they are outliers or have undue influence on the regression coefficients. So here I am taking 3 regression procedures: least square regression, LIU regression, and the robust weighted generalized LIU regression. Least square regression is the most commonly used regression analysis with a response variable and one or more independent variables. The model is given as y is equal to x beta plus epsilon, and the estimator of LS estimator is given as beta kappa plus x dash x inverse x dash y. LIU regression is proposed by LIU in 1993, which is developed for dealing datasets having multicollinearity. LIU forms a new class of biased estimators called the LIU estimators depending on a biasing parameter. By introducing a biasing parameter D, LIU formed a new estimator called beta kappa LR, where D is called the biasing parameter of LIU, and which is calculated by using the given formula D cap, and the value of the biasing parameter D is ranging from 0 to 1. Here I am introducing a new robust weighted generalized LIU regression estimator by modifying the normal classical LIU regression estimator by introducing a robust weight function called Welch weight, and by rechanging or generalizing the biasing parameter D by capital D, which is the diagonal of DL. Then here I am conducting the experimental studies based on both real and simulated data sets. Here I am taking two types of real data sets. In case one, taking half the data set, which has 13 observations and 13 observations with the 4 independent variables. In this data set, which has all the independent variables as high multicollinearity, that is, VAF values of all the 4 independent variables are greater than 10. And this is the basic. There are 4 basic assumptions of regression analysis. This is the assumption graph of half the data set. And in case 2, I'm taking a prostate cancer data set with a 97 observations and 8 variables. In this, only one variable shows the multicollinearity and all other variables are non-multicollinear. And also all the values of VAF values of this prostate cancer data set is lying between 1 and 5. And in the simulation data set, I'm using simulation by normal distribution and taking level of correlation rho as 90%, 95%, and 99% with the number of variables as 5. And by taking the number of observations as in 4 cases with 100, 200, 500, and 1000. So this is experimental studies based on real data sets. In our case 1, hide the data set, the RW with the MSE, R-square, AIC values are produced in brackets. The values are given without outlier. So in hide the data set, by using food distance procedure, there is only one outlier is present, and in case 2 prostate data set, there are 10 outliers are present. So both in the existence of outlier and without outlier, these measures are calculated, and from the table it shows that the RW estimator produce a best performance than the other two. So this is the results of simulation. In which I am comparing various correlation levels with a 0, 5, 10, and 20 percentages of noises for number of observations as 100, 200, 500, and 1000. From all these situations, the proposed estimator RWGL gives a best result than the other estimator. So this is my conclusion. Statistical learning techniques play a vital role in almost all the field of research study. Regression analysis is one of the statistical learning techniques. In general, we commonly use the linear regression procedure will not be sufficient to build a linear regression model when data deviates from the modeling assumptions. Hence, there is a need of alternatives to build a good model for the given data set. This paper explores various regression procedures such as LS, LIU, and robust weighted generalized LIU. Further evaluates their performance on real and simulated data sets by considering the problems of multicollinearity and outliers by computing MSE, AIC, and R-square values. On the basis of computed measures, this RWGL produce a better estimator for modeling the data when data sets having multicollinearity and or outliers. Further, this regression procedure can be beneficial to researchers who work on machine learning techniques by considering the factors such as multicollinearity, outliers, and high dimensionality. These are the references. Thank you.
So this any data set which comes to my mind is share basis. If you see these data, these two data will have both outlier as well as multicollinearity. And the advantage there is that you can also do a backtesting that because you develop the model now and you can just see that how proposing for that first two days. Thank you. So now we move on to the last session in this, sorry, last presentation in this session. Okay, this is from Devidas Rao, and our topic is modeling fraudulent governmental time series, performance evaluation of estimation values across training dispersion.
Good evening, everyone. I'm Monica Sarao. I'm going to present my research paper on modeling short-length count data time series, performance evaluation of estimation techniques across varying dispersion. The count data time series is nothing but it consists of discrete events which are recorded over time and they are typically measured at equally spaced intervals, such as number of road accidents, adverse events in treatment and vaccine trials, number of infectious diseases, many more. One of the main challenges in count data time series is the presence of unique characteristics such as equidispersion, where mean is equal to variance, overdispersion when variance is larger than mean, and underdispersion when variance is smaller than mean. So if these characteristics are not properly addressed, the resulting forecast may be not accurate and which leads to misleading conclusion. Normally, the Poisson and negative binomial distribution are widely used for count data, but they fail to handle over-dispersion. But therefore, the newer methods are evolved to incorporate serial correlation and over-dispersion. Among them, individual value autoregressive model, independently developed by McKinsey and others, become more familiar. They have used binomial thinning operator and Poisson marginal distribution. So the main representation of the model is given in equation number 1. The effect, and after the identification of the suitable count data time series model, it is very important to estimate the model parameters very accurately. The effectiveness of the estimation method is often influenced by the length of the time series. So in the literature, it is given that for the time series model, at least 50 observation is required for the reliable and accurate estimation. But in real-world situation, the situation comes that only short length time series data is available. That is data for few time points. For example, when a new disease emerges, the health organization collect data on the number of cases reported yearly or monthly for the initial 2-3 years only. At that time situation where the period of data collection is very limited, it is very important to model the time series including short length. So in the literature, the several papers have focused on taking INAR model as constant and varying sample size and types of dispersion. Here we can see that in 2015, Marcelo Bardignon, he considered Poisson geometric INAR1 model by taking sample sizes from 100 to 800 to deal with over dispersion. And in 2024, Yakam, he introduced the ZDGC INAR1 model by taking sample size from 50 take all the characteristics of the count data. So overall, they have taken estimation method, CLS, Yule Walker, conditional maximum likelihood, and many more. So in the literature review, what we found that existing research has predominantly focused on data sets with longer time series, that is sample size greater than 50. So there is a lack of comprehensive assessment of suitable estimation technique for handling different types of dispersion, mainly focusing on short length time series data, that is sample size less than 50. So to address this problem, we have conducted a simulation study to evaluate the performance of 3 estimation methods, that is the conditional least square, Yule Walker and conditional maximum likelihood for the 2 models, that is a double Poisson INAR1 model and the generalized Poisson INAR1 model, which is introduced by Marcelo Bardignon to handle 3 types of dispersion, especially for the short length time series data. So this is our first model, that is a double Poisson INAR1 model. So the PMF is given in equation number 2. It has 3 parameters. Alpha, that is autoregressive parameter, which ranges from 0 to 1, and mu is greater than 0, and phi, which is dispersion parameter, which is greater than 0. So according to this model, the equidispersion occurs when phi is equal to 1, underdispersion occurs when phi greater than 1, and overdispersion occurs when phi less than 1. So these are the formulas through which we calculated estimates from CLS and Yule Walker. So next for generalized Poisson INAR1 model. So the PMF is represented in equation number 4. So in this model, the equidispersion occurs when phi equal to 0, underdispersion occurs when phi less than 0, and overdispersion occurs when phi greater than 0. So for the conditional maximum likelihood estimation, for the initial values, we have taken the estimates from Yule Walker method. To check the performance of 3 estimation methods, For the two models, we have considered the simulation setup outlined by Marcelo Bergigno. We have considered two evaluation metrics, the bias and the MSE, and we have taken the sample sizes from 15 to 50 by taking 5 increment. So the value x1 is independently drawn from double Poisson or generalized Poisson distribution, and for the values of xc, we have considered this equation. And we have varied various level of autocorrelation from 0.1 to 0.9 in our set. And for the generalized Poisson distribution, we have considered the dispersion parameter as 0.3, 0.5 and 0.84 to represent over dispersion, 1 for liquid dispersion, and 1.3, 1.5 and 1.84 under dispersion. Similarly, for generalized Poisson distribution, we have taken phi as minus 0.8, minus 0.5 and minus 0.3 to represent under dispersion, 0 for liquid dispersion and 0.3, 0.5 and 0.84 over dispersion. So the parameter mu is fixed as 5 for both of the distribution, and simulation was replicated 5,000 times. And this table represents the estimator of alpha, mu and phi when autocorrelation level phi alpha is equal to 0.5, which represents over dispersion in double Poisson INER1 model. Here we can observe that for the small sample size, the MSE value was moderately large for the lower over dispersion parameter. As the dispersion parameter increases, the MSE value increases very significantly. And we can observe that after the sample size 25, the MSE value became stable. And for the under dispersion case, we can observe that MSE value is very large compared to over dispersion case. For example, in over dispersion case, the MSE value was ranged from 0 to 800, but in the case of over dispersion, the MSE value ranged from 0 to 5,000. And also we can say that even though the sample size reached 50, the MSE value did not become stable. And for the equidispersion case, the MSE value was large up to the sample size 20, and after the sample size 20, MSE value became stable. This is for the generalized Poisson INER1 model. To validate a simulation study, we have done an empirical study. So for that, we have considered a data set which consists of monthly records of number of deaths due to dengue fever in Kerala state from 2021 to 2023. We have considered two data sets here. That is, the first data set consists of 24 observations. For that, we have considered data set from 2020 to 23. And next data set consists of 36 observations. And for to detect whether there is over dispersion and under dispersion present in the data, we have used a test given by Square and Weave in 2014. So for the first data set, that is sample size equal to 24, we observe that over dispersion is present in the data. And here we can observe that for the conditional maximum likelihood estimation method, the AIC and BIC value was minimum. And we can observe that for the generalized Poisson INER1 model, the AIC and BIC value was minimum. Similarly, the same pattern we observed in another data. So the main aim of our study is to evaluate the impact of sample size, level of autocorrelation, and the type of dispersion in the performance of estimation method to identify which is the robust estimation technique to handle short length time series data. So we have considered two models and three estimation techniques. So for the first model, that is the Poisson INER1 model, when the autocorrelation level was 0.5, for all the sample size and the three types of dispersion, we found that Walker estimation method was better. When the autocorrelation level was greater than or equal to 5, for the over dispersion, we found that conditional maximum likelihood estimation was better. And for liquid dispersion and under dispersion, conditional least square estimation was better. And for the generalized Poisson INER1 model, when the autocorrelation level is less than 0.5, we found that Walker estimation method was better. When the autocorrelation level was greater than or equal to 5, for the over dispersion case, conditional maximum likelihood estimation method was better. For the equidispersion and under dispersion, Walker estimation method was better. So we can say that as the sample size increases, level of autocorrelation increases, and the level of dispersion value increases, the MSE value was very large for the under dispersion case. So there is a need to identify, there is a need of suitable estimation method for the short length time series data when dealing with specially under discussion. For the real life data, we have considered the two data sets and we found that conditional maximum likelihood estimation method was better and the generalized Poisson INA1 model was better because of minimum EIs and DIs. So these are the papers we have referred. Thank you.
Any questions? We have a small comment. Meanwhile, is a method for the sample tendency. Whereas variance is a method for starter. How can you compare the two? And if starter is bigger than the mean value, it is something. If the starter is bigger than the sample value, it's something else. This is not something like comparing coconut with mango.
So because the found data time series consists of different characteristics.
Not both functions are some parameters. Meanwhile, character. Not the functions of some other parameters, given parameter. If not, there is no meaning in comparing meanwhile with variance. Or meanwhile with the step. Once the bird is stationary, once the bird is stationary, mean that it will be this way.
Yes, sir. So in infinite dispersion case, the mean value would be so always equals to
mean that's yeah, this is the end of our sessions. So I would, once again, I would like to thank all the presenters on behalf of all of you.
Now, I welcome Dr. Sadish Kumar to present a token of appreciation to Dr. Nawaz Solanki. And Vishal, on behalf of the organizing committee, I extend my heartfelt gratitude to all the presenters for their dedication and scholarly contributions. Your results reflect the essence of innovation and critical thinking. A special thanks to our session chair, Nawaz Jalaldin, for skillfully moderating the session and providing valuable insights. I also express my gratitude to all participants for your active engagement and enthusiasm, which enrich the discourse in sessions like this. Finally, I thank the organizing team for ensuring the smooth execution of this event. Wishing everyone continued success and fruitful networking ahead. Thank you. Today's section. Today's technical sections conclude here. Cultural programs is arranged at Department of Statistics at 6:30 p.m. All are invited there, and after that, a dinner is arranged. All are please. Seminar Department of Statistics.